We are about 29 hours until our earliest opportunity to launch our Space Launch System and Orion spacecraft. You see them live there on Launch Pad 39B here at Kennedy Space Center. When it launches, Artemis I will be humanity's return to the moon in almost 50 years. Good morning and welcome back for another live briefing of our Artemis I mission. I'm Megan Cruz, and thank you so much for being here with us today. This briefing is to update you all on how our countdown is going so far. As you know, the 2-hour launch window opens tomorrow, September 3rd at 2:17 p.m. Eastern Time. Here to take your questions today are Jeremy Parsons, Deputy Manager of Exploration Ground Systems here at Kennedy. And then we also again have Melody Levin, a Launch Weather Officer with the U.S. Space Force. Good morning to you both. We will take opening remarks. Jeremy, let's start with you.
Sure. Good morning, and really appreciate everyone coming out today. Team is doing an absolutely tremendous job moving through launch countdown. And so yesterday at 14:17 local time, we reset the clock to T-minus 45 hours and counting. And so far, they're proceeding right on schedule. Last night, after the briefing, we powered up Orion. We performed all the RF testing. We also powered up the core stage. All looked nominal. We ran final leak checks on the inner tank umbilical. So this was the area that had a leak during launch countdown event 1. Again, all passed ambient along with the tail service mast umbilicals. So good leak checks there. And then yesterday evening, we also completed removing access stands and begin really final launch preps for the umbilicals. What we have on our plate today is a series of launch release system checks. We're charging the batteries on the flight elements, finishing final walkdowns, everyone kind of going through their systems, making sure everything looks and is in the appropriate configuration. We got a really busy afternoon moving everything into final launch configurations. That's handrails, heavy equipment, things like that. When we talk about going into tomorrow and the day of launch, activities pick up really early. So at 2 a.m., we're doing full clearing of the blast danger area. We get into air to GN2 switch over at about 3:30 a.m. And so that allows us to then go into what we have is called a tanking meeting at 4:45 a.m. And we expect to get a decision coming out of there to where we can begin cryo operations at about 5:30. At 8 a.m., you'll expect to get into the engine bleed kickstart. So that's going to be one of those big milestones, again, that we're going to pay attention to. That will go on for about an hour. And afterwards, we'll be into replenish in terms of our commodities at that point for liquid hydrogen. When we get into after that, we have a pre-press test at T-minus 2 hours and 20 minutes. And so that'll be bringing the tank up to flight pressure for a period of time. That's really a risk mitigation for when we get into terminal count, so we don't run into any unexpected issues there. And then right now we're on track for a 2:17 p.m. launch. We have a 2-hour window. And so right now, team has really just done a fantastic job getting us out of launch attempt number 1, repairing all the issues, and getting us into a safe configuration to proceed into tomorrow's launch attempt. With that, that's kind of the quick update. Melody, you want to go through the weather, please?
Absolutely. Good morning, everyone. So the weather continues to still look pretty good for the launch attempt on Saturday. The flow has become onshore this morning, so let's go ahead and look at satellite, and so we can go ahead and talk about what's happening right now. And as satellites being pulled up, you can see there's actually a very weak trough positioned off to our north. And if you're able to focus your eyes just north of the Space Coast, you can see some thunderstorms forming close to Daytona this morning. Basically, that's indicative of onshore flow starting up, and we did see that with our morning weather balloon that was put up in the air earlier this morning. So with that onshore flow regime starting, it should strengthen as we get into Saturday, and that will likely do us some favors as we get into the later portion of the launch window Saturday afternoon. Again, we are expecting our weather to start off a little bit dicey as we get into the 11 o'clock, 12 o'clock time frame. So we'll go ahead and, since I'm already talking about the launch window weather, we'll go ahead and flip to that next slide of looking at that. So our weather is going to start off at a 40% probability of violation, which of course means a 60% go. However, we do start evaluating the weather 3 hours before the launch window opens. So of course, that's right around 11 o'clock or so. So I do expect to make some no-go calls at some point tomorrow. However, as that East Coast sea breeze drifts farther inland, we do expect clearing on the back side of that, and that is because that is the reason why we are trending the forecast to more of an 80% favorability at the end of the launch window tomorrow afternoon. So now we can go ahead and flip to the backup forecast, and that is on Monday afternoon and evening time frame. I have the same numbers that I gave you yesterday, basically a 70% probability of go. However, there's a little bit more uncertainty in this forecast than what we had before. Previously, it did seem like we'd have a pretty steady easterly flow. At this point in time, it does seem like we're going to have a ridge right on top of us in the mid-level layers of the atmosphere. And because of that, it's kind of splicing the flow a little bit more than we expected. To the north of us, we're expecting more on the side of westerly flow, and to the south of us, we're expecting easterly flow. So, of course, we're smack dab in the middle there, and that gives us a very, very light flow regime, and it could almost go either way. So with a forecast like that, basically we're going to be focused on the weather with those inland sea breeze boundaries. And sometimes with that kind of situation, we can see some anvils floating back towards us in general in the late afternoon and evening timeframes. So because of that, I did go ahead and add the anvil rule into the backup launch window. But in any case, like I said yesterday, I do not expect weather to be a showstopper by any means for either launch window.
Perfect. Thank you, Melody. All right, so for the reporters in the room, just raise your hand and we'll get a mic to you. And then for those on the phone, just press *1 to get into the question queue. I saw the first hand over here, Marcia.
Marcia Dunn, Associated Press. For Melody, what's the tanking forecast look like? Because we had a 1-hour delay on Monday before they could even fuel. And my other question for Jeremy is, if you have to delay the start of fueling for weather or for any other reason, is it a minute-for-minute slip in terms of what it does to the launch time, and how's that? Or can you make stuff up as you do other things?
Okay, so of course I'll take that first question. Yeah, I'm glad you brought that up. Because we have onshore flow, we could have some showers approaching the coastline, and maybe a crack of thunder and lightning with that. So that is certainly a threat, again, a very similar threat to what we had the other day. The one difference, though, is we're not nearly as moist throughout the atmospheric column as we were the other day. So that's on our side. But it's very hard to predict shower activity offshore during the late night time frames. It's much easier to predict the onset of the sea breeze than the approaching nocturnal showers. So it's possible that that could be a hindrance, but if we can get past that, I'm pretty confident that weather will be able to press forward for us.
Yeah, and to address your second question, so it's not necessarily going to be it wouldn't be a minute-for-minute slip, and so that's kind of why we want to let the team work through it. They didn't reset the clock until the T-minus 40-minute hold time frame there yesterday. So there's not a lot of margin in the timeline. It's very orchestrated, but they may be able to deal with certain 15-minute delays, 20-minute delays, those sorts of things, and we'll try and make up time as they go through. But I would just say there's not a lot of margin in that timeline.
Okay, and I'll take the next question here.
Stephen Young with Spaceflight Now for Jeremy. After the WDR, you extended some holds to get a little more padding in the schedule, and you've done that again to get the engine bleed, kickstart work in, and pressurize the tank, etc. I'm just wondering if you could give us an idea about the length of the work day for the launch team. When people come in, is it multiple shifts? How does that work? And are there any post-launch traditions that we should expect to see? Will there be beans and maybe a pair of scissors involved?
Great question, and really appreciate that. So we're watching the team really closely. It's not one size fits all, right? So some systems, it may be a couple of different folks going through. When you look at some of the leadership, like Charlie or some of our integration console, they're planned for about 12-hour days. Is really kind of what we're going into right now. If we get into a scrub or at the end of the window, it could go a little bit longer than that. But in general, kind of what we're saying is, 12-hour days is what we're really scheduling them for. We've really been watching the team closely. For example, I'm here this morning so we can give Charlie the morning off, right? And some of the key test conductors and test directors. And so we're just really kind of focused on them. We're talking to them. We're making sure that they feel good and healthy kind of going into tomorrow's attempt and are rested. When you talk about what are some of the celebrations, so we will have beans and cornbread in the Launch Control Center afterwards, and the integration console has all asked Miss Blackwell Thompson to cut their ties afterwards, so pretty excited to see those things. We're also trying to establish a few of our own traditions, and so what you'll see is I'll definitely be wearing a green tie for launch day to show solidarity with some of our launch director and some of the others there.
Thank you for that question. Over here.
Jim McDade, 1819 News. Melanie, could you please give us an overview of the Anvil cloud rule? And yeah, so I think a lot of our readers would like to know more about that.
Okay. Essentially, I can tell you what the rule is based on, and I can kind of give you an overview of why some of our rules exist at all. So primarily, our rules exist because based on two principles. Number one, you can't fly into an active thunderstorm, right? And then number two, you cannot trigger your own lightning strike. And we've seen that in the past at least twice. So basically, if you think about it, we're sending a charged rod up into the sky. We've done half the work for the atmosphere already. So the Anvil rule is just kind of a continuation of that, where basically it's a spread of the electric current possibly along the Anvil, extending farther away from the parent thunderstorm. So because of some of that electric current could still exist, and sometimes it is masked by the outside of the cloud, we don't have a good handle on how to see it and how to read it. So it's just a built-in conservatism into the rule to make sure we don't trigger our own lightning strike.
Okay, we'll go to the phones, and then we'll come back here to the room. I see the two hands in the front row. On the phone, we have Bill Harwood, CBS News.
Yeah, hi, thanks, Jeremy. And I don't know if you can answer this question or not, but you got 46 colas for this launch, and I realize that going up to apogee and then back down to perigee for TLI, you're passing through, multiple realms of satellites. But any idea how Starlink plays into all of that, if it does at all? Thanks.
Let's see, Bill. So honestly, the Space Force does that analysis for us. When we look at it, we got about, like you said, about 45 cutouts. Many are short in duration, typically, a couple of seconds each, with about 10 of them being about a minute each. In terms of what kind of goes behind that analysis, I honestly don't have the answer for you there. It is a mix of satellite position, orbital debris, and things like that. But honestly, the Space Force kind of looks at the specifics with whether it's Starlink or other things along those lines.
Another one from the phone real quick. Kristen Fisher, CNN. Kristen, are you there?
Oh, sorry, guys. Sorry. It took me a minute to get off hold. My apologies. Just wondering if it would be possible to get a update on exactly what the new duration of this mission is going to be. I believe Mike Serafin said yesterday 37 days, but some of our folks at CNN were trying to do the math, and we weren't quite seeing it add up. So could we just get an update on, I believe, the first launch attempt, it would have been 42 days. If it goes on Saturday, how long will the mission be? Thank you.
Yeah, so as you started kind of doing the count, I think a couple of the things that are relevant there is, do you count the launch day? And so essentially that's probably where you're kind of getting a couple of different durations. And then we're also just a couple hours shy of 38 days, I believe. Right now, if we launch tomorrow afternoon, we would land on October 11th at 11:10 Pacific time. So that kind of gives you the duration, and what we would say is it's approximately 37 days to 38 days, depending on kind of where you choose to draw those lines.
Thank you, Jeremy. Okay, here.
Smith, spacepolicyonline.com. If you do have to scrub tomorrow, I gather you've got Monday and Tuesday as possibilities. Is that the end? I mean, at that point, do you have to roll back to the VAB because of replacing the battery in the flight termination system, or are you negotiating with the range to see if they could extend that some more, or do you absolutely positively have to go back to the VAB?
Yes, ma'am. It's a good question. So right now, it's our flight termination system is the kind of the pacing function for needing to roll back after this launch period. And what it is it's based off retest requirements. So right now, the range says every so many days you need to, prior to launch, you have to test that flight termination system. Right now, we worked with them. We provided data for a little over 20 days since we tested it to launch time. we believe we would need to roll back and retest that system just to meet the range requirements. So right now, after 9/6, we'd roll back, retest. We don't actually have to replace the batteries until the next launch period, but it's a relatively short retest of the flight termination system just to provide confidence to the range that the public will be safe.
Follow-up, will you be able to recharge the batteries on the 5 accessible CubeSats while you're back in the VAB?
So I honestly, I can follow up with you on that one. Typically, what we would do is during power up, we're able to recharge, make sure everything's very good. A number of those will actually be charged up on orbit as well, but I can get you a specific answer on that one because I'm not positive.
All right, the front row here.
Thank you. Tarek Malik with the Space.com for Jeremy. You mentioned that there's a possibility of catching up and making up time if you do get delayed on taking it. I'm just curious, where are the windows to do that? Is it just opening the hoses on the fuel line faster to fill or coming out of holds earlier? And how do you make that decision? Thanks.
So there's a couple of built-in holds throughout the timeline. I mean, there's activities throughout all of that. And so if, for example, we get to chill down a little bit quicker than expected or to the 100% filled on the tank and go into replenish. Again, it's minutes that you can make up in a number of those things, but there is not much padding in the timeline. What you saw on the first attempt was, we were probably an hour down due to weather, and as we kind of progressed through the first 4 to 5 hours, we had maybe made up 10 to 15 minutes, that sort of thing. So really it depends on, speed, rate of chill downs. They're not going to change valve positions or anything like that.
We have a question in the third row over here.
Hi. Thanks very much. Trust your arms. Irene Klaus with Aviation Week. I have 2 questions. The first is, were there any other changes made that would cover the last 29 seconds of the countdown that, of course, were not done in the wet dress, but were practiced in the green run based on what you've learned with the sensor configurations and the LH2 flow? That's one question, just kind of to take us through the last 29 seconds of the countdown that haven't been tested yet, and if there's any changes in the process. And then the other question is about the COLAs. How are those accounted for in the countdown? Does Charlie call a hold, or will it be automatically, would the countdown clocks automatically stop, especially if you're already in a termination mode, or would you not pick up the final section of the countdown if there is one of these COLAs in that process? Thanks.
Yeah, no worries. So for the last 29 seconds, no changes were made. Really, in order to kind of maybe get at the base of your question, which was, what did we do to kind of mimic some of the green run activities? That's primarily where we intend to begin the kickstart test. And so that's happening before we get to stable replenish on the LH2 tank. And so we're bringing that much earlier into the flow and before we actually even get the hydrogen tank full. And so that really mimics exactly what we did out at Green Run. As far as when we go into the last 29 seconds and ALS handover, no changes were made based off that. And so a lot of this is a vestige of not getting all of those objectives bought off during wet dress rehearsal 4, and then really wanting to make sure we have strong process control. Let's see, I'm sorry, can you repeat? Okay, so the COLAs, how do we account for that? Thank you for the reminder. So on that one, it really will depend on when we choose to reset the clock. So say we go in, what happens right now is the GLS integration console. So our ground launch sequencer has a series of times of when those cutouts are. And so if we run into any issues, what we'll do is we'll perform an analysis and say, we are good to launch at X time, and they'll reset to that, and then they avoid the COLA. So it's not completely automated, but we do have folks that have those times up, and it's really when we go about resyncing the clock to a new T0 time.
Thanks.
Thank you. Kenneth.
Yeah, hi, Ken Chang, New York Times. So in the last couple of days, we've heard a lot about the hydrogen line bleed kickstart. I was just, and that's to sort of verify your procedures. I was wondering, once that all sorted out, in a normal countdown, when does the engine chill down occur?
Okay, so let me try and get to the core of your question. So when do we kind of, maybe I'll repeat it back. So when do we validate our new procedures? Is that the question?
No, assuming everything works the way you want it to this time. So for Artemis II, when would the chill down actually occur during a normal countdown?
So the kickstart procedure is something that I do think we will do every single flow, and so we'll know that relatively early on. What we are doing this time around that we would not necessarily add into future tests is a pre-press test, and that's just us kind of getting into understanding exactly what the controls are, how everything's behaving, and that's really going to be a risk mitigation to the terminal count. But I do believe we will not continue to do, or we will do the kickstart similar in every single flow.
And what time in the countdown would that occur later?
So right now, it's going to occur at approximately 8 a.m. I don't have the T-minus time right on me, but it should occur about 8 a.m. for about an hour.
No, in the future.
It would be at a similar time.
Okay, thanks.
We have some questions on the phone. We have Jim Siegel, NASATech.net.
Oh, thank you for taking my question. If the launch moves to Monday instead of Saturday, when will the launch window open? And I assume that it'll still be a 2-hour launch window. Thank you.
Let's see. So our launch window opens, it's a couple hours later. I don't have that exact information with me handy, so I'll have to get back to you exactly at that time. And so I'll just follow up if you don't mind.
Yeah, absolutely. Jim will get back to you on that one. And then we have Anthony with main engine cutoff on the phone.
Hey there, thanks for taking my call. For Jeremy, if the crack on the core stage foam yesterday was mentioned that's not an issue for flight, are there any other areas on the core stage where that would be an issue, and how are those monitored?
So we do a series of checks throughout launch countdown and actually in between the last attempt and this one where we go through, we do thorough inspections of the vehicle. Even very minor defects are noted. Throughout launch countdown, we have a team which we call Sea Ice on the console, and they do inspections throughout. So they use high-definition cameras, infrared, things along those lines. And so right now, we've done a full inspection of the vehicle. We've noted any nonconformances, and they've cleared any of those for flight. Throughout the count, as we see cryo pumping, things like that, we're going to continue to do the same thing. If anything is anomalous, they note it, and then they turn it over to a debris trajectory analysis team to decide whether or not we have any concerns. So they have standards that they use against, and they have models that we run it if it's above those standards. And then just to answer the other question, it was 5:17 p.m. is the launch time, and I believe it is a 2-hour window as well.
5:12, actually. 5:12 on me. Yep. Nope, it's okay. It's 2:17 Saturday. so 5:12 on Monday, no problem, with that 90-minute window to answer Jim's question from before. And we had a question in the room here. Yep.
Aaron Cooper with CNN. Knowing everything you know, can you kind of bottom line it for us? How confident are you that this is going to fly on Saturday? How confident are you it's going to fly before the end of the Tuesday windows?
Yeah, so this is a test flight, right? And so while I feel very good about our procedures, when you look the team in the eye, they're ready. We can't control the weather. And so on any given day, there is risk that we'll be able to get off. I think what I kind of am looking at is our team is ready. They are getting better with every attempt and actually performed superbly during launch countdown number 1. So in my mind, I think if the conditions with weather and the hardware align, we'll absolutely go. And we have the right team at kind of the right time. So, and those statistics, right, those probabilities go way up if we get 2 attempts off before the end of this window.
And I believe there was another one in the room. Was there another hand in the room? No? Oh, over here.
Hi, I'm Brandy Campbell with Fox Weather. With the weather being favorable at 60%, how often have you guys had a successful launch at that, rate? And with that being the rate, do you foresee us maybe waiting a while for like a good time to take off, or is there a chance we could take off, at the beginning of the window?
Those are excellent questions. I don't have the exact stats that you're searching for. I can get back to you with that. I can tell you, though, that on any given day, there's about a 1 in 3 chance that we will scrub for any reason. And out of those chances of us scrubbing, there's a 50% chance that it's due to weather. So hopefully that's some stat you can take back. Could you remind me of the second part of your question?
Yes, I was asking, is there a chance that we might have to wait a while for there to be a good opportunity for us to launch throughout that weather, being that it's a 60% chance favorable?
It's entirely possible, and that's why I trended the forecast as such I did today, making it worse at the beginning of the window and a little bit more favorable at the end. It really all depends on that sea breeze and whether it moves inland as fast as we are expecting. If we are looking at the balloon data in the morning and that easterly flow is not nearly as established as we were hoping to see, we could run into a situation where we're red a little bit longer than we expect to be. But overall, that sea breeze does tend to win out with easterly flow, regardless of truly how strong it is.
Okay, we don't have any other questions on the phone. If we're done here in the room, then I think we can wrap up today's news conference. Again, thank you, Jeremy, Melody, and everyone who asked questions. For more information on Artemis I, we're going to pull up some resources here on the screen. You can take a look at this website. Also follow us on the social media channels you see there. Coverage of us tanking our moon rocket will begin at 5:45 a.m. Eastern Time tomorrow on NASA TV. And then our live launch coverage will begin at 12:15 p.m. For our Spanish viewers, our Spanish launch broadcast will begin at 1 p.m. We hope you can join us. Thanks so much.
EV2? Well, EV2 is a sublimator already off.
Ну, хорошо.
Okay. Do the EV1 then.
If you're just joining us, good morning and welcome to Mission Control Houston. You are currently seeing a live view outside of the International Space Station. Today's operations is a Russian spacewalk, 54A, where two cosmonauts exited the hatch at 8:25 a.m. Central Time, 13:25 GMT, and we are looking at a 6-hour and 18-minute spacewalk today. Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev, both of Roscosmos, exited the space-facing Poisk module. The primary objective of the spacewalk is to relocate an external control panel for the arm, the European robotic arm, from one operating area to another, and test a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads.
Наблюдаем ваши картинки, так что по мере не укладок, пожалуйста, прошу доклад.
We are not getting a video, so please provide voice commentary for your kit operations. Okay, one hook is done. You take that hook. Got it. Closing this one.
Just entering orbital daytime as the ISS flew 262 statute miles above the North Pacific Ocean.
Hey, I'm passing you the second hook now. Okay. Second hook is outside. Okay, now the cube. Okay, I am passing you a hook now. Okay.
Сейчас, подожди секунду. Геннадий, можно автоматически СТР включить?
Gennady, is it possible to have auto STR on?
Проверьте среднее положение.
Yes.
Тепло-холод.
Please make sure heat cold switches in middle position. The two in 0 and turn on.
Так, 0, среднее. Так, я включу.
EV2 has auto thermal control on.
Принято. Первый, второй.
Ditto, EV1. Copy, EV1, EV2. Okay, don't pull because I am not done with the second hook yet. Hold on.
Зацепил первый.
Okay, hook 1 attached. Okay, start retracting.
You're now seeing great views in the center of your screen of Expedition.
And here comes the second one. I got the second one.
You're seeing Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev. Artemiev is wearing the Russian Orlan spacesuit with red stripes, while Matveyev is wearing the Orlan suit with the blue stripes. This will be the 8th spacewalk for Artemiev and the 4th for Matveyev. Today's spacewalk will complete unfinished tasks from a spacewalk in August, which was cut short after Artemiev's spacesuit showed abnormal battery readings about 2 hours and 17 minutes into the spacewalk. The battery has been replaced and tested. During the previous spacewalk, Artemiev and Matveyev completed the installation of a pair of cameras on the arm and removed parts attached to the arm's end effector before the spacewalk ended.
Should I put it here? As you wish.
The European robotic arm, which launched last July attached to the Nyoka module, will be used to move payloads and equipment outside the Russian segment of the station, joining the Canadian-built Canadarm2 robotic arm and the Japanese arm already supporting station maintenance, operations, and research.
In this case, Oleg, please start executing as you are ready. Okay. Okay. Let me grab this.
We're currently in a brief handover between satellites, and we'll have camera views of the EVA back in just a few moments.
Okay, give me the fixed length one. This one goes outside. No, cannot do it like this.
You're currently seeing a live balcony view from the Russian International Mission Control Room in Koryov, Russia, outside of Moscow.
Okay. Okay, one hook is attached outside. Oleg? Yes, go ahead. No, just what... Wanted to let you know that you are go to turn on helmet cameras once you're outside. Okay. Okay, both hooks are outside. Please check that there is no interference in my path. Your go. Okay, EV2, gas temperature, inaudible. Copy, Denis. But feeling fine. EV2 has two cameras. Okay, please check my suit. Okay, one.
We now have live views of the duo outside the Poise module. They're here gathering adapters, and then they'll translate over to their work site of the MLM, or the multipurpose laboratory module, also known as Nyoka.
Okay, it is on. Can you help me turn on the lights? Of course.
The crew is currently in the process of turning on their HECA, or their helmet cameras. We'll see those views shortly.
Okay, I am next to you.
Нет. И второй.
And the second one.
Вот есть. Два.
Got it.
Два горят с одной стороны.
Both are on.
Сейчас поближе. Два есть. А у меня вот с этой стороны включил.
Okay, turn it on for me on that side. Okay. Hold on.
Отлично.
One more time. So the lights are. Make sure the lights are on.
Тогда начинаем.
Okay, the lights are on. Copy.
Блок на себя повесил или нет пока еще, Олег?
Talking over each other.
Нет, мы включали же фонари.
No, we were doing the lights.
У меня уже 2 раза с языка вопрос снял сегодня.
Inaudible.
Так, сундук на мне.
Okay, I got the bag.
Так, и теперь работаем по переходу на кольцо.
Now we start translating to the ring.
Так, Денис, там далеко не уходи.
Denise, don't go too far.
Так, один карабин на кольце.
One hook is on the ring.
Второй карабин на кольце.
Second hook is on the ring.
Давай мне это. Вот один.
Now pass me that.
Вот один.
Here's one. Here's the other.
Контролирую тут.
Please watch me.
Все, я пошел на стрелу, ты там как-нибудь подождем, как ты тут запутался.
Okay, let me untangle this a little bit.
Ага.
Просьба в процессе перемещения с адаптерами.
Inaudible.
Что?
What did you say?
Контролировать, удерживать ее в процессе перемещения, это у нас тяжелый.
As you translate, make sure you watch the status of the platform. It's massive and has to be handled with care. Okay. So let me watch the. Oh, actually, pass me the tether first. Okay. Hold on. This is the tether for the platform, right? Yes, it is. Okay, now watch me execute. Now pass me your tether. There you go. Okay, take this. Okay, too bad you don't have a second pair of hands on the back. Hold on. Are you holding it? There's a bit of a spring action. Okay, pass me the second one. All right. Okay. Can you manage by yourself? Sure. All right then. Where's the cube? Oh, there it is.
Так, ты его пока держи, а я буду расфиксировать кольцо.
You hold this, and I will undo the ring.
Так, кольцо расфиксировал.
Okay, the ring is undone.
Ну что теперь? Так, билеты проверили, места заняли.
Okay, so the tickets have been checked. The passengers have taken their seats. It's time to depart. Okay, off we go on the Strela.
По стандартной этой схеме будете проходить ПФО, там аккуратнее.
Okay, talking over each other. Yes, I will be following you.
Вот так вот.
Мы стали получать картинку с ваших камер.
And you're currently seeing the helmet camera, helmet cam 16 of
I need to pass
Oleg Artemiev, and we know this is Oleg due to the red stripe Orlan, the Russian spacesuit.
Так, не застрял еще? Да, вроде нет.
Are you there? No, I'm still with you.
Так, ну мы подошли к месту перехода.
Okay, we are at the transfer point, and we need to secure the ring. So we need to put it right here.
Помнишь, как мы договаривались еще ручку немножко ослабить своим ключом?
Oleg, remember, we need to...
The duo is currently translating or moving to their work site, which will be the base point of the MLM or the multi-purpose laboratory module with the platform and adapters.
We still need to get to the end. But if you go there, you won't be able to reach.
The primary objectives of the spacewalk are to relocate an external control panel for the arm from one operating area to another and test a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads.
Okay, can you reach those handrails? Let me try. Hold on, let me secure myself here.
Получается, мы кольцо тогда не за поручень будем цеховать, а за поручень стрелы.
So we're going to attach to a Strela handrail. Artem, can we do this? Yes, you can even use the lanyard.
Рукой, может быть, попробуешь этот барашек, он насколько...
But why don't you try seeing how much it can move? The wing nut. Well, the wing nut is tight, but I can release it.
Буквально, да, полоборота.
Yeah, give it a half turn for initial torque.
Короткий перерыв связи.
Had a short LOS.
Да, хорошо было затянуто.
Yeah, it was tightened really well.
Теперь нормально.
Now it's in good config. Okay, we are now going back.
After a brief reacquisition of the signal, we now see a view of the Russian cosmonauts outside of the International Space Station. If you look to the bottom left of your screen,
An alternative would be to
the duo is translating to the Nyoka module, where they'll be working to move a control panel from one position to another.
quite a distance to descend.
Одинаково идти, что так, что
Inaudible.
Давай. Денис.
Олег, Денис. Go ahead.
Действительно идти примерно одинаково, что по первой плоскости, что по третьей. Вы как хотите, как удобней?
For you, it is the same distance if you go via plane 1 or plane 3. So, which route do you want? Well, we're heading back already. Let me turn around, and then you will hand me these items. This one? Okay, I'm already here. Hold on, let me figure it out. Time to explore the new paths, since Artem gave us a go. Do I need to untangle this? Okay, I have translated to FGB. You can hand me the kit now. Okay? I mean the hook. Right, let me undo it.
Наших камер. Так что просьба докладывать, на каких поручнях вы находитесь.
Please report the handrails you're attached to. I am on handrails 4010, 4011, EV1 on FGB.
Олег, оговорочка, это MLM.
Oleg, you're an MLM, right? Oh, yes, MLM.
If you're just joining us, you're seeing live views outside of the International Space Station of the Russian segment. We're about 30 minutes into today's spacewalk, Russian Spacewalk 54A, where two cosmonauts exited the hatch at 8:25 a.m. Central Time, 13:25 GMT. Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev are conducting today's spacewalk. Today's approved task, and currently where the astronauts are heading, is to their work site on the Nyoka module, or the multi-purpose laboratory module. They will install work platforms, relocate the European Robotic Arm external control panel, adjust and test the European Robotic Arm's end effector grasp capability. They will remove a launch restraint on one of the European Robotics Arm's end effector, and if time is permitting, they will jettison launch restraints and protective covers and extend one Straya boom from Zarya to Poisk.
Attach right here. Good job. Where do I put the second one? Oh, you can pass it to me and I'll attach it for you. Hold on to the ring. Oh, I thought you were pulling it. Or you can just reattach. Okay, like I said, hold on to the ring and pass me the hook. Okay.
Так вот. Все. Давай, переходи. Сюда. Хорошо. Я тебе сейчас... Давай,
Translate here. Okay. Now take the platform.
Все, взял тупик. Все. Посиди на пенечке. Так, это мы на горбушке.
Okay.
Нам надо вот туда.
Okay, we're here on the hump and we need to go right there.
Да, можно. Сейчас видим. Так, давай мы все от кубика.
We currently have great views of the cosmonauts at the bottom of your screen as they translate to their work site, and we have a view of the European robotic arm.
Так, давай, получаем видео.
Okay.
Keep
now let's activate the video.
The first thing the cosmonauts will do will be to install work platforms on Nyoka.
Please report your position.
На 40. 06 и 4007.
My handrails are 4006 and 4007. EV1.
Ты идешь первым, да?
And
Talking
you're
over
going
each other.
forward, right? Yes.
Подожди.
Stand by.
Hold on.
Фиксирующую 15.
I'm at plate 15.
Так, есть. Готов. Или давай я приступу, пойдем.
I can rehook you here.
Держи кубик, я потом дальше. Взял кубик.
Okay, I have it.
Перестыковался на 4023.
Rehook to 4023. Copy.
Второй карабин на 4021.
And the second hook on 4021.
И полкубика тоже сюда. Так. Сейчас вместе еще одну пересадку сделаем. Давай. Вот так все можно задержать.
We have to hold on here a little bit.
Так, один карабин на съемном поручне.
One hook is on a removable handrail.
Карабин на 4321.
4321, one hook is on there.
Переменной длины.
Adjustable.
Так, теперь я полностью на продольной курсе. Так, и давай теперь кубик. Все. Давай, я его контролирую.
And I am monitoring. You hold on. Okay.
Все, я как кубик контролирую, здесь переходит.
I am monitoring the cube and you are translating.
Так, второй карабин.
And the second hook is where?
Так, и второй карабин транспортировочный видишь, да?
Are you able to see it? Yes, I am.
Так, Артем, ты как вас слышишь, видишь?
Artem, are you able to hear
Я вас слышу,
us? Are you able to see us?
доклад отличный.
Not able
Ты уже полностью на третьей плоскости.
to see you. Though. You are on plane 3 already, completely.
По поручню 40.05 он идет.
Yes, and keep moving.
Так, готов взять кубик. Так, все, Денис контролирует кубик.
Now, you watch the cube, and I am moving it to the rail.
Мы уже на оперативной прямой.
So you are on the way straight there.
Да, Денис, давай мне кубик.
Dennis, give me this cube.
Все, отпускай.
Okay, now release, and I'm holding it.
Да, кубик пересел горбушку.
Now, over the hill here for the cube.
Так, нормально.
Looks all right, looks all right.
Ну, давай потихонечку. Только на этот поручень два карабина не...
Now, slowly, but don't put both hooks on the same handrail.
А тут перекрепить.
Rehook it this way.
Съемные, ну...
There are connectors here.
Так, есть.
Got it.
Держи кубик. Сейчас, погоди. Взял. Да, сейчас я...
I got it.
Так. Так, все. Прошли этот поручень, я тебе вот сюда, а тут ты уже тут на этот... Да, я дойду. Да. Сейчас я чуть отойду.
Just keep going. Give me space. I am ready for the cube. Okay, hold on. I do have it in my hands. And I am passing by the panel with replaceable pumps. Copy pump panel.
Олег, Денис, как у вас теплоощущения?
Alec, Dennis, how's your thermal situation? Good. It's better and better. And we are on handrail 4320 to 27. And, okay, so you are looking and I am moving. Okay. In work. And where are we? Got it. That's closed. That looks good. Unintelligible. Let me try move a bit away. Okay. I'll just get over here and be ready. Okay.
If you're just joining us, we are about 50 minutes into today's spacewalk, Russian Spacewalk 54A. Expedition 67 Commander Oleg Artemyev and Flight Engineer Denis Matveyev ventured outside of the hatch at 8:25 a.m. Central Time, 13:25 GMT. Artemyev is wearing the Russian Orlan spacesuit with red stripes, while Matveyev is wearing the Russian Orlan suit with blue stripes. We are currently seeing Heka helmet cam views from Matveyev. Artemyev is helmet cam 16, Matveyev is helmet cam 20. This is the 8th spacewalk for Artemyev and the 4th for Matveyev. Today's spacewalk will continue unfinished tasks from a spacewalk in August, which was cut short after Artemyev's spacesuit showed abnormal battery readings. During the previous spacewalk, Artemyev and Matveyev completed the installation of a pair of cameras on the European robotic arm and removed parts attached to the arm's end effector before the spacewalk ended.
I understand. You are by Nauka module. And we see the cover that is to be removed.
The European robotic arm, which launched last July, attached to the Nauka module, will be used to move payloads and equipment outside the Russian segment of the station, joining the Canadian-built Canada Arm 2 robotic arm and the Japanese arm, already supporting station maintenance, operations, and research.
Let me catch it.
Все, держу. Сюрприз большой.
The duo is currently translating to the base point of MLM, or the multi-purpose laboratory module, also known as NIOCA.
I crossed over the gap. Okay. Let me hold it. Okay, holding it now.
Their first task will be to remove protective covers from the base point and install a work platform on NIOCA.
Take the adjustable. The protective cover has been removed. Is it on the adjustable? On red. At this time, I will secure it on my side. This will need to be rehooked. So which hook? This one, and we'll swap them. Yes. Let me orient it, and I am holding it now. So hold on, I'll take care of the hook. And yours as well. Okay. Where's the lock? Okay, I will be pressing, and you go ahead, press the lever. Okay. Okay, let me rehook again because I'm being pulled. Okay, stand by. Need a bit of time. Now you press. Turn. And lap. Okay, great. It is locked. And the platform with the adapter. Okay, are we late? How are we doing with time? No, you're even a little bit ahead. Almost minute, 2 minutes. How about resting? Just a little bit. Just make sure all is secured and the locks are locked. And secured. Great. Okay. Now rest a little bit. Just take care of the cover. Dennis, how about I'll give it to you?
После того, как вы освободите вот эти мягкие поручни и чехол, у меня просьба к вам
When you release it,
на камеры, как установлено на платформе с адаптерами. Хорошо.
use the
30-40
cameras.
Спасибо.
Just make sure we have the image. Okay. And I am hooking up now. Okay.
Так, накидку вернули. Так.
So we returned the protective cover. Now I'm removing the tethers.
Наконец появилась картинка с ваших.
Now we finally get a picture with you.
Ну тогда вот смотри.
Okay, now take a look.
Нет, я смотрю, но надо для истории заснять, пожалуйста.
But for the history, for the record, we want to have pictures.
А я пока файл. Или ты мне выпускал?
Okay, I'll work with the tether this time.
Свой сундучок. Очень солнце светит. Сейчас отсюда. Так. Так. Держи один. Доброжит.
Hold one and let me hook the other one.
Должен сундучок влезать. Но у нас он беспилотный. Сейчас облетит.
Just make sure it does not fly away.
Так, давай.
And the second hook, give it to me.
Так, сейчас вызову опять сундук.
Looking good.
Так, теперь другой файл.
Now the other tether.
Ты можешь с той стороны снять?
Can you remove it from the other side? Possible? No, on my side only.
Все. Сейчас опять вызову сундук.
Done.
Так. Отлично. Отлично.
Great. Great.
Так. Так. Все файлы на месте.
All tethers are in place.
Какой интересный файл мы наблюдаем на крылок-бэге.
That's an interesting
Да, у тебя сейчас будет минутка. Можешь
tether.
включить свою?
Так, а как она включается? Кнопкой? Кнопкой, да.
How
Да.
inaudible.
Она у меня, по-моему, работает.
I think this one is working. Make sure the camera is working.
А Герку или Секу?
This is
Хек ты сейчас, видимо, отключил. Ты.
Heka or which Heka? Which one should I make sure it's working? Heka, I think.
А теперь включил.
Okay, I'll turn it on again.
If you're just joining us, we are about an hour into today's EVA, or Russian Spacewalk 54A. You're currently seeing live views of the Russian International Mission Control Room in Koryov, Russia, outside of Moscow. Two cosmonauts, Expedition 67 Commander Oleg Artemiev and flight engineer Denis Matveyev ventured outside the hatch at 8:25 a.m. Central Time, 13:25 GMT. The duo currently have translated to their work site, and they've done their first objective, which was to remove protective covers at the base point of the multipurpose laboratory module, or NIOCA, and install a platform with adapters at the base point. The duo are currently translating to the European robotic arm. They are about 5 minutes ahead of their current timeline.
adjust this.
Как здорово. День рождения выходить.
That's great.
Сегодня еще этой у Ирины, которая нам географию преподает.
So that's a birthday, Irina's birthday. She is a geography teacher.
Ребят, если вы передохнули,
Okay, if you rested enough,
тогда выключаем камеры и
let's turn off the camera. And translate further.
Выключаем камеры.
We are turning off the cameras.
Подольше. Она держать. Да, подольше там. 2-3 секунды. Она должна
Just 2-3 seconds and it will turn off.
сигнал подать.
There should be a signal.
А, вот все.
Okay, it's not blinking anymore.
Ага. Все, у меня тоже не мигает.
Okay, mine is not blinking either.
Вы во время съемок СМ снизу снимали?
Did you also record what's below you?
Первую плоскость СМ.
SM, the first plane of SM, was it in view when you were
Вы общий обзор делали на СМ?
doing it? Well, actually, we have not, since you didn't ask.
Несложно, Олег, там буквально на...
No, if you want, we can turn the cameras on again and do this. Yes, please. Okay.
У нас с этого ракурса фотографии СМ почти нет, поэтому...
We don't have images of the service module from this angle. All right, we'll do. Just a second.
У нас через 5 минут день начнется, так что мы успели вовремя заснять.
So in 5 minutes, it will be dark. So you have enough time to take a picture. All right.
Все, Олег, спасибо. Я думаю,
That's all, Alex. Thank you. That would suffice.
А третью плоскость снять СМ?
Do you want a picture of the third plane of service module? Actually, when we go back to MRM, you will be able to take a picture at that time. Okay?
сейчас нам надо намного больше других задач сделать.
Now we'll keep going the timeline.
Все, камеру выключил.
Okay, the camera is off.
Так, ну что, пора в путь дорогу.
And keep going.
Пульту, правильно?
Да, к внешнему пульту идем.
And we are going to the control panel now. Yes.
Это рядом.
And that is close by.
Так, о, отлично, вот он.
And here it is.
Он прям рядом.
Так, сейчас подожди, там карабинчик.
Just taking care of this hook.
Для этой работы с внешним пультом шпаргалки не нужны. Нужно будет перевести в режим Для этого я сейчас расскажу.
I will tell you what exactly to do. We don't need any additional support to this one, and you will have to put it in the upper position. The diodes should be lit up, and on our go.
Мы находимся в зоне МДДК, поэтому еще раз напоминаю.
We're in the area here, and just a reminder: be careful.
Так, я на позиции.
So I'm in the required position.
Открывай.
Go ahead and open it.
Так, внешний чехол открываю.
Okay, opening the outer my cover. It is now open.
Открываем?
Am I going to open it? Yes, Yura.
Когда откроешь,
Okay, it is now open. And Oleg, stand by for now.
Хорошо.
Copy.
Ничего, даже не смотрю на него.
Okay, I'm not even going to look at it. Okay.
Горит он.
Да, мы
On is illuminated. Yes.
Верхнее положение.
We received a go.
If you're just joining us, we are 1 hour and 5 minutes into today's spacewalk, the Russian Spacewalk 54A, where cosmonauts Oleg Artemiev and Denis Matveyev are outside doing some upgrades for the European robotic arm.
Which is in the top.
We just entered into orbital nighttime as the International Space Station was flying 267 statute miles above the Indian Ocean.
No, I haven't done anything yet. So what should I do first? Brightness. So please.
Artemiev and Matveyev exited the hatch at 8:25 a.m. Central Time, 13:25 GMT. They then translated to their first work site.
What's next?
And have now made it to their second after removing protective covers and going to the European robotic arms control panel.
So I have executed 2 steps.
We're currently seeing helmet cam views from Artemiev's suit.
And then power. Okay, it is deactivated now, and LED is not illuminated. Okay, go ahead and cover it.
His task will be to remove the European robotic arm from hibernation mode and turn it off.
Didn't work. Okay, cover installed, and now installing the outer cover.
Чехол закрыт.
Outer cover installed as well.
Так, Артем, что дальше делаем?
Artem, what's next?
Не слышно. Так.
I guess you didn't copy. Yes, we're standing by for now.
Слышно?
How do you read me, guys?
Извините, тут да, все принято, Олег.
I copied that it is off. Yes, copy, Oleg.
Ты на СБТ можно расстыковывать разъем Х2.
And Dennis, you are going to make the launch base point connector. The latch will now be unlatched. It is open now.
Олег, держи.
Oleg, please hold it. Oh, and what is it? Okay, stand by.
Ты расстыковал его, да? Уже получил.
Okay, did you reconnect it?
Да, расстыкован.
Yes. It is dematted. Then the cover that was secured is installed, and I'm gonna hand it over to Oleg now, and then I will start operations with the connectors.
Да, нам нужно упаковать этот кабель.
So we need to pack up this cable.
Слишком сильно не надо, Олег, да? Помним, что у него...
Inaudible. So I'm holding it. Let go.
Его прям сильно затягивать не надо.
Do not
Сильно затягивать.
tighten it too much.
Заделка так, ну, нежная.
What was it?
Слабенькая, да.
I'm saying do not tighten it too much because it's fragile, as you remember. Okay.
We're currently in a brief handover period between satellites. We should have views outside the International Space Station back for you shortly. Currently have a live view inside the Russian International Mission Control Room in Koryov, Russia, outside of Moscow.
Oleg, Denise, on ISS, how do you read me? Loud and clear. Copy.
Так, кабель предварительно уложили.
Okay, so the cable is temp stowed. Copy.
Теперь один карабин.
And one hook, I guess, should I attach it on my tether? Yes. You can drop it on your short tethers.
Так, один карабин на мне.
So one of the hooks is now secured. And the connector is capped.
After installing a dust cap and removing the protective covers from the European robotic arm, the duo is now translating to the base point of MLM, or the multi-purpose laboratory module.
It is now demated from the lock. Denise, this one is yours.
Мы если его не снимешь, пока мы адаптер зачем. Ну ладно.
So we were
Подожди, давай я уже...
transferring the adapter. Okay, all right. So let me tether it first, and I'm gonna hold on to the control panel now. Okay, and also, as agreed, I use 2 points. You can install the long one on the ring and the short one inaudible. Okay, so the adapter is now tethered. Copy.
На себя надо потянуть его, и защелка должна выйти.
You should pull it. The latch should disengage.
Да.
It got stuck. Yes, I see that it is sort of sticky. No, it's moving now. Okay, go for it.
Как бы не свернуть его.
Make sure that you don't over. Is it tight? Yes, it is. It feels quite tight. Okay, Oleg, please check if the bushing is sticking out or not. No, not yet. It should not. Because a year ago, we had a similar nominal situation, so that's why I'm asking. Actually, it's out now.
Так, сейчас, подожди, я полетаю.
Okay, stand by. Yes, can you see it? Yes, I guess you need to press on the hook here to make sure it's retracted.
Так, ну давай.
All right. So you can drop this hook on your tether. Got it. It's done. Okay, let me take a breath here and we'll keep going then. All right. Are you monitoring it? And inaudible. Yes, the flashlights, do we have them? Yes. And Denise, did you attach the safety hook to your tether? Not yet. All right, I am monitoring it. Okay, so I'm holding it. All right, so I have it now. You have it? Yes, correct. Good. All right. So we have reached the adapter.
Так, сейчас. Воздушно влетает. Сейчас его в сторону.
Okay, so let's move this box to the side now. Make sure it's not in the way.
Так. Все, давай, контролируем. Давай.
There, are you watching it? I'm watching it. Do you have it? I have it. And please make sure you're careful with the target on the QRM adapter. Make sure you're monitoring it. Okay.
Так, ты пришел? Да, ты пришел.
Okay, so did you already move over here? Yes. And the target is somewhere here. Actually, there are two. And please do not touch either of them. Make sure there is no contact with the target. Copy.
Сегодня надо было чехол. Так.
So we just needed to deal with the cover here. It's on this side. Copy.
Так, Денис. Давай.
Денис,
Аккуратно, аккуратно.
I'm ready for the handover. All right. It's in work. Please be careful.
На себя и по кругу.
Okay, so pull towards yourself and then rotate.
Так, а давай я свой карабин перестушу.
Okay, so let me reattach my hook here first because you can see what it's like now. Okay. Okay, so the target is here. Inaudible. Moving on.
Так. Давай контролируем.
I'm watching it now. All right. I'm going to start moving. Okay, Oleg, I have already moved closer to you. Okay, so let's swap the tethers again. Okay. All right. I am monitoring it now.
Так, мы прошли 4108, это туда, куда ставить.
Okay, so we're next to 4108, Hendrio. Is it the location for the install as well? Yes, you're going to install the tray adapter.
If you're just joining us, you're looking at a live view from helmet cam of Denis Matveyev, EV2, on today's Russian Spacewalk 54A. Expedition 67 Commander Oleg Artemyev and flight engineer Denis Matveyev, both of Roscosmos, exited the station's space-facing Poise module at 8:25 a.m. Central Time, 13:25 GMT. And we're looking at about a 6-hour and 18-minute spacewalk today.
My recommendation is for you to...
Artemyev is wearing a Russian Orlan spacesuit with red stripes, while Matveyev is wearing a Russian Orlan spacesuit with blue stripes. Today's spacewalk is a continuation of unfinished tasks from a spacewalk in August, which was cut short after Artemyev's spacesuit showed abnormal battery readings about 2 hours and 17 minutes into the spacewalk. During the previous spacewalk, Artemyev and Matveyev completed the installation of a pair of cameras on the European robotic arm and removed parts attached to the arm's end effector before the spacewalk ended. The European robotic arm, which launched last July, attached to the Nyoka module, will be used to move payloads, equipment outside the Russian segment of this station, joining the Canadian-built Canadarm2 robotic arm and the Japanese arm already supporting station maintenance, operations, and research.
Fully set, not fully in position, which is different from the hydrolab training.
The duo have already completed one thing that's part of their planned task, which was install a work platform on Nyoka. The duo then translated over to grab the European robotic arm and turn it off on its control panel, and they are now in translation back to the base point. of the multipurpose laboratory.
So manual mode would be sufficient. Okay, copy.
Снимаю страховку.
All right, so I am releasing the tether. Okay, Oleg, once you do it, could you please reconnect the aircraft camera?
Включил.
It is.
The primary objectives of the spacewalk are to relocate an exterior control panel for the arm from one operating area to another, and to test a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads.
Oleg, make sure that your safety tether is stowed near handrail 4108 to avoid any issues in the future. Yes, I got that.
Давай, я контролирую.
Denise. So I have it. I'm holding it. Okay, let me move. You need to rotate the control panel by 180 degrees. Yes, indeed, we need to do that, but it's too early for that because Dennis is still moving. And his hook is actually dropped on the other side. So it's the tether is extended. I can't do it now. Okay. All right, so here I am. Okay. So what we need to do is to figure out the tethering here. Hold it, please, and I'm going to...
The duo just completed their translation with the control panel. Next task will be to install a tray adapter and then install the control panel to its new position.
All right. Now on my side, yes, exactly like this. Do you have the second tether? Okay, here it is. All right. Go ahead and hand it over to me. Excellent. It did not float away. Okay, now we need to engage this lock. So what's in the way there? Okay, there you go. Okay, half a turn. That's it. Okay, so the control panel is set, installed. So now, keep moving over there. Okay, I see it. Okay, I see the connector and the cap can be freely removed. It's all nominal. So, did you get a chance to make phone calls and congratulate? everyone. Sure. Okay, so this is the connector, the parent connector. Oleg, Dennis, how do you read me? Loud and clear. The control panel is installed, tethered. The cable has been released. Okay, and we just received the go to make the connector. Please repeat your last. I said X2 connector. What about the contact surface? Is it nominal? Is it clean? Yes, it is clean. Looks nominal. I can see the connector now. Be careful.
Okay, moving it to the end. Can it reach? Yes, we have to bring it to the end. Hold on, check the latch. Well, they look nominal. They don't appear to be changed. Ball is aligned with the arrow. Did you adjust it? No, it's in the nominal position. What about the latch? The latch is open. Seems to be getting stuck there. And the latch is not closing as well. Is there a lock on the cover? Yes, it has a small latch. Well, you need to close that one and tighten it. Okay. Well, it is closed on one side, but not on the other. I'm maintaining matching configuration on both sides, so the marks are aligned on that other side. Are you using the right connector? Yes. X2. Now it's pushing against the wall, and now am I supposed to latch it? Yes,
Okay, I'm turning it over. Did it install?
You're currently seeing live views from a balcony camera inside the Russian International Space Station. That is not right. You are currently seeing live views inside the Russian International Mission Control Room in Koryov, Russia, outside of Moscow. If you're just joining us, we are having a live spacewalk today for Russian Spacewalk 54A. Duo Oleg Artemiev and Denis Matveyev ventured outside of the hatch at 8:25 a.m. Central Time, 13:25 GMT. The duo is currently installing a tray adapter for the installation of that removed control panel.
Artyom, a copy. Guys, we are experiencing
The primary objectives of the spacewalk are to relocate that external control panel from one operating area to another and install it. And then they will test a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads.
the shroud open. Do I need to open the cover? Yes. Denis, please assist. Okay.
Олег, Денис.
Oleg, Denis. Go ahead.
У нас сейчас такая плохая связь, что по шпаргалкам работать будет неудобно.
Our comm now is so bad that we will have a hard time executing off of cue cards. So, Oleg, we want you to proceed with your task. And Denis, please assist by holding the cable. Okay, will do. Thank you.
Денис. Да.
Denis,
У меня просьба, можешь кабель
go ahead.
максимально увести от Еры?
Can you please move the cable as far away from ERA as possible towards the external panel?
Без излома, соответственно, чтобы.
Without kinks, of course.
Нас смущает вот эта петля, чтобы Ера за нее не цеплялась.
We are a little bit concerned about the loop on the cable because ERA can get caught in it. Okay, will do.
Now 1 hour and 44 minutes into the Russian EVA 54A. Today's spacewalk will complete unfinished tasks from Spacewalk in August. Prime objectives is to now install a control panel removed from one sector to another, and then we'll be looking at a test at a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. That's the end effector, or that hand of that European robotic arm.
Okay, one gap.
So far this morning, cosmonauts have installed a work platform on Nyoka module, and they have relocated the external control panel. They are currently looking at hooking up cables for that control panel.
Sergey, if you can hear us, please call MCC on space to ground 1. Will do. Oh, we hear, Sergey.
Денис, да, можешь еще раз показать повнимательнее?
Again, that's after installing a tray adapter in the control panel. They're looking to put in the cable at the base point for the control panel.
Спасибо, да, нам нравится.
Thank you. Looks good. Very good. Well, it's not every day that we do something that Artyom likes. Okay.
Сейчас пока тебе особо делать нечего, у нас скоро будет отдых, когда
Okay,
работает с пультом.
Denis, you will have a bit of a time off,
Кольцо, которое на прошлом выходе.
so maybe you can use this time to remove the LFM ring
Подвяжешь уже на это кольцо.
at the and then take the ring and secure it on the base point. Second gap spanner is installed between 4107 and 4125.
Размещайся у внешнего пульта и будем работать. Связь вроде бы устойчивая.
Okay, please position yourself at the external panel and we will start our ops. Looks like we have good comm.
Здесь уже нужна
So, do we need cue cards? Yes, we do.
на внутренней шине.
We're going to initialize the EMMI on the internal bus. The cue card is inside the cover. Right now we're standing by for a go, and we'll pick up our steps afterwards.
Олег, приступаем. Тогда
Okay, Oleg,
питание в положении on.
we can start. Power switch to the on position. Complete.
Принято.
Copy.
Дальше, как тебе удобнее будет, чтобы я диктовал по шагам?
Do you want me to read the steps to you, or do you want to do it yourself? Okay, why don't you read the steps to me and I will check them off. Okay. Step 1. Auto menu line has EMI config.
Шаг 2. Тумблер старт.
Confirm. Step 2. Start stop switch to the stop position. Complete.
На третий меню автоменю выбор языка.
Auto menu language selection. Complete. Start-stop switch to start position.
Есть старт, есть бак.
Complete. Switch in start position. Battery 1553 visible. Copy. Step 6. Start-stop switch to start position.
Есть MMI ID.
MMI ID visible. Copy. Step 8. Start-stop switch to start position.
Здесь мы будем ожидать выполнения проверок
Here
и загорания всех дисплеев.
we will stand by for checkout and elimination of all displays. Yes, checkout in progress.
Появится MMI 1 ECC English.
We are standing by for MMI 110, etc. Copy, I see the message. Copy. Menu line should have the start-stop switch check step.
Да, старт. Предлагает нажать.
I see start and the prompt to start. Copy. Step 12, press start on start-stop. Complete. Prompting to start-stop. Should I start-stop? Stand by.
Working with MCCM, that's Mission Control Moscow, Oleg Artemiev, EV1, is powering up the control panel.
Then, yes. Start, stop, and stop position. Okay, prompted to press end emergency. Copy. Move the emergency switch to lower position. Complete. Prompting to move it back. Copy. Step 19, moving to the upper position. Complete. Copy. Right now, we're not getting FOR data after internal ops.
Да, сейчас будем выдавать команды изнутри.
Okay, we're about to send command, so let's take a few moments to catch a break.
Идем с опережением порядка получаса.
Elapsed time 1:52. We are ahead by about 30 minutes.
One hour and 52 minutes into today's Russian EVA or Spacewalk 54A. The crew is currently reporting they are about 30 minutes ahead of the timeline. The duo is currently being seen outside the Nyoka module with the European robotic arm. They are currently installing a control panel that they removed from a different location and now are looking to work with Mission Control Moscow to get the control panel powered on.
Do you see those forest fires? Oh, that is impressive. Looks like it's the States.
Сейчас западное побережье Америки.
Yes, you're flying over the western coast of the U.S. Yes, we recognize it.
Прием, как слышно?
How copy?
Да, слышим тебя хорошо.
Loud and clear.
Что делаем?
What are we doing now?
Олег, ожидаем где-то через минуту.
Oleg, we're standing by for another minute.
После этого
We expect FOR data to show up.
Currently in between satellites, we are looking at a live view inside the Russian International Mission Control Room in Koryov, Russia.
Okay, we had a brief LOS. So, in about 1 minute, we're going to get FOR data on the panel. Once we verify that, we're moving to plane 3 with KRM. For Denis, can you attach the initial base point cover to the ring so we will save the time for the future? Sure, I can do that.
Прием, как слышно?
How copy? Loud and clear.
Посмотри, пожалуйста, появились координаты. Слышно хорошо.
How us? Loud and clear. Please check if you see the coordinates on the panel.
Координаты есть.
Yes, coordinates are visible.
Спасибо. Тогда
Thank you.
BTL-3.
In this case, move to BTL 3.
Так, пульт закрывать?
Okay, should I close the panel?
Оставь его в таком положении. Мы еще с ним будем работать.
Negative, leave it as is. We will work with it later. Okay, BTL 3. Where's that?
А ты располагайся у индикатора.
Okay, I get it. At Denise, please position yourself near TRM indicator such that you can continue operating while we wait for internal commands to execute. Okay, Oleg, please check if it's closed. Yes, it is closed. So they don't see the rocket on the launch pad. Yeah, it was closed by the cover, the cloud cover. So let me get over to this side. It's getting more difficult to walk around here, right, just like on the service module.
If you're just joining us, you're seeing live coverage from the helmet cam of Russian cosmonauts Oleg Artemyev and Denis Matveyev. We're 2 hours and 1 minute into today's EVA, or spacewalk, where the duo have prime objectives of relocating a control panel and then testing out the grappling mechanism on the end of the European robotic arm.
So the indicator is in the firm position.
The duo have translated to their work site after exiting the hatch at 8:25 a.m. Central Time, 13:25 GMT. They have installed the control panel at its new destination and are looking to install gap spanners. The duo are about 35 minutes ahead of the timeline and are looking to do some get-ahead tasks, including the removal of some multi-layer insulation.
So you're saying the translation from the panel to BTL is difficult? Yes. We should have put the gap spanner of 4109. Okay, so how about we reattach it to make the translation easier? I think it makes sense. At least we could try. So you want to reattach to 4108? I'm afraid the length will not be sufficient, but we will try. Yeah, it was not good, and now it's even worse. You see the opening under your right hand? The camera is flapping around there. Yes, this is what happens when you translate like this. That wasn't like this in the Hydrolab.
So, how about this? Once we finish with the panel, close the panel, then you will take time to evaluate the translation paths. It should be from 4127 to 4109. And the alternative would be 4128 to 4110. It's just that these tethers are pretty short. They may not be enough to reach the handrail. Okay. Is it time to start with the aero tool? So, inaudible.
And then assess the position, should be 4 meters from the control panel. From era 1, that is in the center. Copy. That's some bundle.
Вставлять в отверстие нельзя.
So make sure you don't use the service, the install. No, don't install. Okay. Okay, understood. Does it look like the cover got ripped? No, it was like that before. On the handle. Yeah, so that it was before. Maybe it's not needed actually. These are the ones that were here before. Yeah, the cover is still here. Artem, can you find out maybe those covers are not really needed on the handrail?
Кураторы говорят, пока пусть будут.
The operators believe they're needed. Actually, the other handrails, the same kind, did not have any covers, and those are throwaway kind, paper made. One of them is torn. But the operators say keep the covers for now. Copy.
Нас ожидание где-то еще порядка 3 минут.
Just waiting for about 3 minutes.
рукой. Денис, а у тебя руки свободны?
Dennis,
Можешь, пожалуйста, сфотографировать?
if your hands are free, would you mind taking a photo of this cover on a handrail just for further analysis? No, Alec is in the way. I'm on the other side. Okay. Then later, when we wait for automatic adjustment, maybe you will take a picture at that time.
If you're just joining us, you're having live operations of the Russian Spacewalk 54A, where 2 cosmonauts exit the hatch this morning at 8:25 a.m. Central Time, 13:25 GMT. The duo are looking to finish up some work that was started in August on the European robotic arm. The prime objectives were to relocate a control panel and then test out a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. So far, the duo have completed that first task where they have relocated the external control panel for the European robotic arm. They then will have gaps. They're looking now to install gap spanners and move on to their next primary task, which will be to adjust and test the European robotic arm, its end effector and grasping capabilities. Here they're looking to see the strength of that grapple or that hand, as it will be used to move hardware and equipment around the module of the Russian segment. Two of 3 cosmonauts are outside the station. Expedition 67 Commander Oleg Artemiev in the red Orlan suit, or the red Russian space suit with the suit with the red stripes, and Denis Matveyev, the Orlan suit with the blue stripes. And then there is one more, Sergei Korsakov is inside the ISS, looking to help out the duo when it's time to test out that European robotic arm scrapping mechanism.
Олег, Денис.
Alec, Dennis.
Нам дано добро переводить ТРЛ в положение флекс. Для этого
We have go to switch theorem, and that is 1.5 torque counterclockwise.
без фиксации, по-моему, да.
Without lock wire, yes, without locking. Let me support. Installing.
Вот, слава богу, ставил.
Okay, it's installed. So 19 revolutions counterclockwise. 1, 2, 3, 4. So this one is in firm position. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Now stand by.
Так, Артем, значит,
Artem.
оказался в окошке на 18 оборот, а на 19 он ушел.
So on the 18th we were in place. At the 19th revolution, we moved away from the desired point by a quarter unit. Okay.
Спасибо за доклад, Денис. Сейчас мы...
Dennis, thank you for the report.
Подходит это или не подходит?
Let us analyze.
Это вот он был ровно посередине.
So 18 was exactly in the center.
Мы сейчас ожидаем проверки на пульте, и после...
We are waiting to check out at the control panel at this time. Did it change the lens here? Yes. Looks clean.
Олег, Денис, все, дано добро переводить в положение ферм.
Alex, Dennis? Now 19 turns clockwise in firm position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, we got it in the window. And that is at the not 19th, at the 17.5. We had short LOS. Please repeat.
Now, 2 hours and 17 minutes into the Russian Spacewalk 54A, 2 cosmonauts are outside the Nyoko module, where they are currently using the European Robotic Arm 1 tool.
No, Alec, more instruction. We need one more turn, so please insert it again. Okay, now this paper flew away.
The duo is working with Mission Control Moscow to configure the control panel for the European robotic arm.
I'll try.
The duo currently is about 35 minutes ahead of their timeline.
So how do I turn? Clockwise. One turn clockwise. Done. Now the indicator is moving away by 1/4 from the window. Well, they decided to adjust it a little bit so that it will automatically even out with the given number of turns.
Все, теперь точно вынимаем ключ.
Now definitely take out the wrench. Are you sure?
Да, точно.
Yes, sure.
Сейчас абсолютно.
Absolutely.
И будем контролировать дверки.
Take it out.
У нас в автоматическом режиме будет.
Now we'll be
Как договаривались, Олег,
checking this in automatic mode. But do not put the wrench too far away.
когда во флекс автоматически перейдет. И тогда уберем.
We'll have to make sure that the automatic checkouts will go smoothly. And when we confirm that, you will be able to tuck away the wrench tool. Copy.
Мы сейчас прошли шаг 24.
We are done with step 24 and keep moving. The sensor is in a flex position now.
Олег, давай тогда будем убирать ключ. Вроде все нормально.
Then let's take away the ERA 1 tool. Are you sure?
Так, дальше что делаем?
What's next?
Дальше мы еще ждем, когда перейдет в положение firm.
Now we are waiting for the indicator to go to firm position.
Как ты думаешь, лучше вам идти?
And then you will translate to BTL to base point. How do you think it will be better for you to get there? Please repeat. We are waiting for the firm label to appear. And then you will have to translate to the next work site. Do you want to go via the adapter area or no? I think it's better we go in a straight path. Will you have enough reach? I think so. Now let's confirm that the indicator is showing TRM firm label. The indicator is in firm position. Thank you. Now we'll go to the LFM ring. And the firm indicator is in the middle, mostly in the middle. Not quite centered, but mostly in the center. Maybe 1/10 to the side. Static unintelligible. Unintelligible, static. You will attach the areas that are going to be removed initially, unintelligible the rest.
Дай мне мой файл. Пожалуйста, сейчас, секунду.
Okay, keep moving.
Спасибо.
Thank you.
If you're just joining us, we are 2 hours and 30 minutes into the Russian Spacewalk 54A, where Russian cosmonauts Oleg Artemyev and Denis Matveyev of Roscosmos exited the station at 8:25 a.m. Central Time, 13:25 GMT. The duo have been completing tasks quickly this morning and are currently about 35 minutes ahead of their timeline. The primary objectives have been achieved. They have relocated an external control panel for the European robotic arm, and they have also began working on the end effector of the European robotic arm.
Hold on to the handrail. I am.
After translating to their work sites this morning, Oleg Artemyev and Denis Matveyev installed a work platform on the Nyoka module. They have relocated the European robotic arm external control panel, and they have adjusted and have begun testing the end effector grasp capabilities.
The bag is stuck. Just a second. That's a good setup. On the other side. We'll be removing LFM ring. Security. MLI cover will need to be secured first. Done. Copy. Now take it off. Okay. Alec, now secure the long wire tie to the eye bolt. The one on the left side.
No, just pull it. The one that you're handing, the one next to the tool. No. I don't think that I can pull it like this. That's it. I think it's now bent pretty well. I see that you have different ones. Excellent, that's great. That's it? Okay, so I got the wire tie. Now we just have to remove this one. Well, make sure that you secure the ring first using the wire tie. And also, you have to secure the cover using a wire tie. Okay. And also, just a heads up, you have eclipse coming up in 3 minutes. Inaudible. Should I tether it here as well?
If you're just joining us, we are covering live coverage of the Russian Spacewalk 54A. You're currently seeing helmet cam from Russian cosmonaut Oleg Artemiev, where he and Denis Matveyev are working on end effector 2 of the European robotic arm.
Are you going to use the regular tool? Yes, actually, we can give it a try. We got it done last time, like this. Actually, you have a special era tool. So if you can't do it with the ratchet wrench, you can use that tool. Please do not remove it just yet.
The duo has installed a working platform with adapters on Nyoka module. They have relocated the control panel to the base point. They have installed gap spanners, and they have calibrated the European robotic arm end effector 2. They are currently looking to remove multi-layer insulation and the LFM ring from the European robotic arm end effector 1.
Some more. I did half a turn. Well, I guess this cover needed to be removed. Okay, so there it goes. Keep going. Great. I guess this one is tightened way more than the other one. We need to tether the ring. It is already secured. Actually, I removed it. That's all you did. Yes, in that case, it needs to be secured. Inaudible. So why did you remove it? Because I needed to attach the wire tie and twist it. And the wire tie had to go through it. Okay. Can you reach there with your fingers, do it manually, or do you need the ratchet wrench? Can you push it slightly? Let's try this one. No, this is the top one that's rotating. I guess we need to go some more. Let me hold it then. Okay. Go ahead and spin it. Which way? To open, yes, that is correct. I think you set it to close now. Okay, well, that's it. Keep going. Keep rotating. It's not moving back, as you can see. It's not working. The ratchet wrench is not working. All right, so let's try the wing nuts then. Okay, let's use mine because it's easier to reach. Keep pulling. No, actually, no. Can you see it? No, it's not moving. Can you see it? What is it? Okay.
Заклинило. Она у тебя заклинила там. Ладно, давай. Боимся. Что у вас заклинило?
What got stuck?
Кольцо стало в раствор.
Well, the ring, the safety, the ring is in the way, and we can't pull out the wrench.
Сейчас я приплыву к тебе.
Let me move towards you.
Ставить? А ты, может, попробуешь повращать?
So let me set it there first, and you'll try rotating it. Okay, stand by. Okay, you can give it a try now.
Ого. Тяжело идет. Но идет.
It's not easy to move, but it's moving still. Yes, that's right.
Давай.
Okay, go ahead.
Ага, все.
All right, that's it. Did you say it's done? Yes, you can take it now. Can you take it? Are you taking it? Yes, but the Jasmine here, well, it's inaudible. Okay. And let's attach an adjustable tether here, okay? Well, Oleg, can you do half a turn for the ring first? Inaudible. Let me help you. I can hold it if you'd like. Okay, so what should we do? I guess the wire tie goes here. I'm holding it. You can hand it over. Like this. Okay, so let's try turning it now. Okay, well, this is better. Now you can take it off. Actually, you can remove yours now, and I'll wait for now. Okay, I have it. Let go. Okay, and you can hold it now. So what should we put here? A cover? Yes, you should wrap the MLI cover around it. And where is it? Where is the cover? Okay, there it is. Let's start on your side. Let's start on your side, Oleg. Okay, there, hold it, please. Do you have it? Is it good? Yeah, okay, MLI is installed. Oleg, do you have wire ties? We can actually bundle the two rings together in one unit. Well, actually, you should have enough wire ties for everything, to bundle everything up. Yes, and also MLI has been installed, and I still have the wire ties. I have some wire ties as well.
If you're just joining us, we are currently live with the Russian Spacewalk 54A, where Expedition Commander for Expedition 67 Commander Oleg Artemiev and Denis Matveyev exited the hatch at 8:25 a.m. Central Time, 13:25 GMT. They then traversed to their work site, where their prime objectives were to relocate a control panel and to work on the end effector for the European robotic arm. The duo has completed a lot of their beginning tasks, and they are now about 50 minutes ahead of their timeline.
I can hold it for now. Okay.
The pair are currently working on the removal and bundling of multi-layer insulation and launch fixture mechanisms. The ring attached to the end effector and arm for when it launched back in July of last year attached to the Naoko module. It is no longer needed and will be bundled, and the team here in Mission Control Houston are working with controllers in Moscow to see whether jettisoning will occur today.
So we just put them together, right? Correct. Okay, we'll get it done. And you can do it on the other side as well. Okay. Okay, should we install one more wire side here? Yes. So make sure that nothing gets detached, that we don't remove anything. Okay.
Флаг, Денис, у тебя на левом плече.
Denise, inaudible on your left shoulder. I don't see it.
С камеры Олега наблюдаем.
We are seeing you through Oleg's camera. Okay. Like this? This is better because the second ring is only secured by a wire tie. Okay, this wire tie has been through 5 EVAs. This one has shown itself on the battleground, and now they just want to trash it. Do not let it happen. Okay, it's done now. Excellent. So now what?
Дальше мы
The ring has been removed, okay?
рамкой с защитными стеклами.
Now you'll move on to the protective window activity.
После рамки. Сначала мы делаем рамку с защитными
First, you're going to do all of the operations for the protective window. You'll remove the old one and install the new one.
Мы дальше перейдем к Flex Next Firm.
And then we will switch to inaudible. All right. So we need this camera. Is that correct? Yes, is that correct? Level 1, yes, correct. Okay. And this looks great. Okay. So I guess we need to secure it too. Okay, I'm ready to take it now. Okay. There is no room here. Okay, let me move over here. Okay. Hold it, please. Okay. Ready? Ready. Wow. It's not going easy at all. I remember it was easier last time. Okay. Are you holding it? Yes. And you're not using any tools, doing it manually. Okay, got that. So shall we try it? Okay. No, that's it.
If you're just joining us, we are 3 hours into today's Russian Spacewalk 54A, where Oleg Artemyev and Denis Matveyev have been outside of the hatch, outside of the International Space Station, performing work on the European robotic arm. So far, the planned task, the crew is doing well, and they are about 50 minutes ahead of their timeline. They have installed a platform with adapters on the Nyoka module. They have transferred the control panel and reinstalled it. They have also done work on the end effector 2 and end effector 1 with the removal of multi-layer insulation and the LFM ring, which is the launch fixture mechanism ring, which is not needed for orbital operations.
Radiators. We have switched to the ISS broadband communication system. How do you read me? Loud and clear.
The crew and the International Space Station are currently flying 261 statute miles above China.
Last time I was on the other side, and it's not working when I'm on this side. Should we swap places? Well, let's try this. You hold this piece and that thing. Hold, like this. Let me get this preliminary restraint. I think the MLI is interfering. Or what? What are you saying? The MLI is interfering. Okay, let me detach this. Now move this away. Okay, now it should fit. There you go. Okay. Okay, let me tighten this one a little. Okay, torque range. Okay, use Era 4 tool. Era 5 is also a torque wrench, but we no longer need it here. It will be required later. Oleg, Denise, we are going to lose calm for about 10 to 12 minutes. We're going to lose video for about 10 to 12 minutes, so please provide voice commentary. Will do. And eclipse in 5 minutes. Copy. Installation in 5 minutes, sorry. Okay, ERA 4 tool. Okay, Denise, where are you? I am right here. It should be primed for closing. Yes, if you remember, we practiced this step. Okay, there you go. Okay, now I have to back out this fastener. Are you okay working like this? Yes. It's a little bit short. Say again. I just need to get back here to keep it from flying away. Okay, this one's ready. Now the second one. You ready? Okay, this one's removed. Okay, protective frame is installed. Copy. MLI is installed correctly. The frame is removed and can be stowed in the kit. That has been done already. So what do we do next? Now we will work with TRM. Unstow ERA 1 tool and position yourself similar to your last. Ready. Indicators is done. Copy. Now standing by for our go. Oleg, Denis. ERA people are asking that you do not hold on to the ERA handrails. They will be doing some arm commanding. Okay, hands off, ERA. ERA handrails. Thank you.
If you're just joining us, we are 3 hours and 13 minutes into live coverage of the Russian Spacewalk 54A. We had two cosmonauts, Oleg Artemyev and Denis Matveyev, venture outside of the hatch at 8:25 a.m. Central Time, 13:25 GMT, where they have now completed two of their major objectives, which was to remove and replace a control panel from one section to another, as well as do some testing for their end effector on the European robotic arm. So far this morning, the duo have installed work platforms on the Nyoka module. They have relocated European robotic arm external control panel. They have adjusted and tested the European robotic arm's end effector grasp capability, and they are currently working to remove the launch restraints of one of the European robotic arm's end effectors. They'll be working with Mission Control Moscow to give them a go on how to set the end effector 1 into a firm configuration with using the European Robotic Arm 1 tool.
Oleg, Denis.
Денис, как слышно?
Oleg, Denis, how do you copy? Go ahead.
Получили добро на продолжение работы.
We are go
Регулировки ТРМ.
to continue ops. You will now perform TRM adjustment/override. For that, you will insert the tool into the slot and start operating. 19 revolutions counterclockwise. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. At revolution 18, the window started showing the visibility, and at 19 it was fully visible. Denise, can you take a photograph of the arm in this config? I'll try. The photograph may not be visible, very clear because of the illumination conditions. Well, whatever you get, we'll be happy to receive.
Так, Олег, спасибо, Денис, можно переводить в положение firm.
Oleg and Dennis, thank you. Oleg, you are go to put it in the firm position, 19 revolutions clockwise, and do not retrieve the tool. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the tool is out of the slot. Okay, we did 8 turns. So, clockwise, right? Nine. 10. 11. 12. 12.
You're currently watching live coverage of 2 cosmonauts outside the International Space Station as they do work on the European robotic arm. You currently see the helmet cam of Oleg Artemyev as he and Denis Matveyev work with Mission Control Moscow to put the end effector 1 into a firm configuration with the European robotic arm 1 tool.
17.
You'll hear counting as they are going and supposed to have 19 revolutions of their tool.
Have 2 more to do.
The duo is working efficiently and suits are working well. They are about 50 minutes ahead of their scheduled timeline.
It's partly visible in the window. You can do. Okay, now the indicator is smack in the middle. Okay, we are standing by for a minute now.
Сейчас Денис ожидается уже через секунд 20.
Okay, Dennis, we are waiting for the turn state. Okay. Indicator is in the expected position. Copy. Okay, can you please repeat? So it's in the middle. It overshot a middle by about a quarter dial. Copy. I think we can stow error 1 tool. Okay. Stowing error 1 tool. Since you said so. Error tool is stowed. Copy. Okay, standing by for a couple of seconds. Okay, I see the indicator crossed the middle, but it did not reach the expected position by about 1/5 of a dial. Okay, copy. Dennis, can you please photograph this config? And Oleg, we are still standing by. Smile, you are on camera. Let me take a selfie as well. Oleg, Denis, please turn away from the camera. The laser is about to come on. Stand by, please. We need to move the camera away. Okay, so after you deal with the camera, start translating towards the panel. Okay, I have turned away. EV1 has not turned away yet. Okay, EV1 has turned away. All right. You are now go to start translating. The laser will come on after you leave this area. So Denis, you go first, go to grapple fixture of the arm, and Oleg, you will be at the external panel. Okay. Am I going to be able to translate over handrail 4127?
If you're just joining us, we're 3 hours and 33 minutes into today's Russian Spacewalk 54A, where cosmonauts Oleg Artemiev and Denis Matveyev have been outside of the International Space Station on the Russian segment doing work to the European robotic arm. The duo are currently translating to the base point of the MLM, or multi-purpose laboratory module, also known as NIOCA, with the LFM ring, or the launch fixture mechanism ring, and the bundles of that multi-layer insulation.
Dennis, are you in place? Yes. Stay there. I will come over. That's a gap spanner. Yes. And the second one. Hold on. And one more. Okay. So on 2 gap spanners, yes. Alec? When Kira is moving to start mode, maybe that will be a good time to work with the gap spanner. What exactly to do? To adjust the path at your discretion. Well, it is too short, unless we put 2 together. Otherwise, it is short. It goes between these 2 parallel ones, but does not reach the spot. Maybe 4108 to 4109. Maybe we can do this. That's the option I wanted to propose. Or around the control panel, maybe 4108 and to 4106. Why would that be needed? It will be to go around the control panel. Actually, 4108 to 09 would be the best, probably, to have access to ERA and such. 4108 and 4109, it will take 1 gap spanner. And the other one will be able to attach only at one end. You know, after covering the control panel, we will take another look and make a decision.
Ну так, конечно, вот этот 4109, 4108 было бы неплохо. Просто момент, что за один порч сразу 2 карабина будет.
It's just that there will be 2 hooks connected to 1 handrail.
Сейчас скоро будут лампы включаться. Олег.
Laser is going to be activated now.
If you're just joining us, we are 3 hours and 38 minutes into the Russian Spacewalk 54A, where the duo Oleg Artemyev and Denis Matveyev have been outside the International Space Station on the Russian segment working on the Nayoka module, doing some work to the control panel for the European robotic arm. The duo just translated from one location to the base point of the MLM, or the multi-purpose laboratory module, or Nayoka, where they are now looking to bundle the LFM rings with the protective coverings. LFM is the launch fixture mechanism ring, which is not needed and was removed from the end effector 1.
You can take the retainer and attach it to the grapple unit. Okay.
After bundling, the crew is looking to do a crew rest for about 9 minutes. The crew can choose to take or move forward into their timeline. The crew has already skipped 2 rests, so they may take this one. However, the crew is working efficiently and the suits are working properly. The crew is about 1 hour ahead of their scheduled timeline.
And we'll use a small red. Okay, let's take the small one. Release yours. Got it. I got it. Now, place the cover.
Ты можешь пока под шпаргалку
Lock it in.
точки управления и выполнения ручных операций.
And now you can use the cue card for the rest of the operation. Okay.
Олег, Денис, предупреждаю, будет скоро включение лазера, так что...
Alec, Dennis, laser is going to be activated soon. Okay?
Сейчас начнется движение манипулятора, Олег.
And the arm will start moving now.
Да.
Okay? And what do we do?
Наблюдать,
Observe.
наблюдаться и находиться в безопасной зоне.
And be in a safe area.
Смотреть на внешнем пути телеметрию.
You can check telemetry on the external control panel.
ручки, да, на такелажном узле.
And the handles on the grapple fixture, right?
It currently looks like EV2 or extravehicular crew member 2, Denis Matveyev, has moved to get ahead task, and he's now translating to Australia 1 in effector and removing handles to do the Australia 1 retainering. EV1 or extravehicular crew member 1, Oleg Artemiev, is currently in a rest period. Oleg Artemiev is in the Orlan Russian spacesuit with the red stripes, while Denis Matveyev is in the Orlan Russian spacesuit with the blue stripes.
And how the handle needs to be oriented.
Ну, надо блокираторы под лееры.
To the retainer after the era.
То есть новый блокиратор, у него ручка, по-моему, должна в бок стрелы сейчас.
So facing toward the Streeler, and if we're talking about the new retainer.
включение лазера, не смотрим на камеру.
The laser is being activated. We're not looking at the camera. Okay.
Так, ну я поставил это.
I installed the retainer.
Ну, тогда размещайся на СТУ.
Very good.
Дальше на нем будешь ждать Олега.
Now we'll keep moving. You will be away from Oleg.
If you're just joining us, we are 3 hours and 54 minutes into today's Russian Spacewalk 54A. Expedition 67 Commander Oleg Artemyev and Flight Engineer Denis Matveyev, both of Roscosmos, exited the station's space-facing Poisk module at 8:25 a.m. Central Time, 13:25 GMT. Artemyev is wearing the Russian Orlan spacesuit with the red stripe, you see right there in the center of your screen, while Denis Matveyev is wearing the Orlan suit with the blue stripes. This is the 8th spacewalk for Artemyev and the 4th for Matveyev. Artemyev is helmet cam 16 and Matveyev is helmet cam 20. Today's spacewalk will complete unfinished tasks from a spacewalk that was started in August, which was cut short after Artemyev's spacesuit showed abnormal battery readings. During the previous spacewalk, Artemyev and Matveyev completed the installation of a pair of cameras on the arm, the European robotic arm, and removed parts attached to the arm's end effector before the spacewalk ended. The European robotic arm, which was launched last July attached to the Nyoka module, will be used to move payloads and equipment outside the Russian segment of the station, joining the Canadian-built Canadarm2 robotic arm and the Japanese arm, already supporting station maintenance, operations, and research. So far today, the crew has been very effective, and they are about an hour and 10 minutes ahead of their planned schedule. So far, they've installed work platforms on the Nyoka module. They have also relocated the European robotic arm external control panel. They have adjusted and began testing on the European robotic arm's end effector, or its grasping capabilities. They have removed launch restraints on one of the European robotic arm's end effectors. The crew is currently doing 2 different tasks, where EV2 Denis Matveyev is moving forward in the Strela 1 retaining. And that's the Strela boom, where they were going to move one to the Poisk module. Extend one Strela boom from Zarya to the Poisk module. Denis Matveyev has started that task, while Oleg Artemyev is currently still working alongside the external control panel.
Олег, Денис, время.
Alec, Dennis? Yes, go ahead.
Артем, мы тебя слушаем.
Yes, Artem.
Говорю, время за бортом 4 часа ровно.
4 hours even you have been EVA.
Мой совет вам, поэкономьте батарейку для ФГБ.
And advising, save the battery for FGB. How exactly?
На камерах, на видео.
I mean video camera. Video cameras. Save the battery. It still has 5 bars.
Да. Да. Видеосъемку и размещаться возле пульта. Уже буквально через 3 минуты.
You can start recording and get situated next to the control panel. We have about 3 minutes.
Сейчас даже раньше уже.
Even less.
Нам дано добро на работу.
We have a go to keep working with the control panel.
Взятие точки управления на Эми.
Use a cue card
Шаг 1.
with step 1. Make sure the indicator will get illuminated and the coordinates are displayed.
Тумблер.
Displayed.
Рабочие ожидания.
And the toggle switch in the work arm position
Горит тумблер.
Is the LED for the switch illuminated? Which switch? This is the LED next to the manual switch.
Нет, горит автомат.
Next to the switch, so no, automatic mode is illuminated.
И тумблер вручной.
Please put the switch to manual. Done.
Теперь давай возвращаемся к шпаргалке. Тумблер.
Now let's go back to the cue card. Switch to operating position, standby.
Так, Артем, ты на связи?
Artem, are you here? Yes, I'm online.
Ты молчишь тогда?
How come you're silent? What step are we in? Step 2, switch to operating standby.
Ожидание сделал.
It is in standby, completed. It's blinking.
И появился статус сообщения, да?
And did you get the status message?
Да. Airport wait start.
Yes, POC, white start. Okay, it's blinking, right? The LED is blinking, start LED is blinking. Should I press on start? Yes, please press start in step 5.
Выдал.
Completed.
Что через 30 секунд на дисплее.
Stand by for 30 seconds.
Инфодамп есть.
Info dump confirmed.
На том же самом дисплее появится сообщение SBOP.
SBOP message will come up on the same display next. Standing by.
Есть сообщение SB Opograph.
SBOP grapple message came on.
Ожидание, зеленый светодиод, ожидание загорелся.
And did you get the standby message and LED should be green? Yes, I confirm all.
Автомат ручной, переводим в
Please put switch to manual.
Переведено.
Or is it in manual already? It is. Well, actually, automatic mode is illuminated now. Well, in that case, please switch it back to manual.
Перевел в ручной.
It is in manual.
10 тумблер, рабочее ожидание.
Switch to operating standby.
Standby.
Confirmed. Standby confirmed.
Ожидание.
В ожидании.
It is in standby, not in operating mode.
Перевести в рабочий.
Надо перевести.
So should I put it to operating mode then? Yes, please do so. Thank you.
Перевел.
Completed. It is in operating mode now.
Шаг 11. Тумблер координат, фрейм вверх.
Step 11. FOR, switch to up. Copy.
Так, есть. И волоска, да?
Completed. And is it Alaska next? No, please stand by. So should I move the frame up
If you're just
now?
joining us, we're about 4 hours and 10 minutes into the Russian Spacewalk 54A,
Now?
where two cosmonauts, Oleg Artemyev and Denis Matveyev, have ventured outside of the hatch at 8:25 a.m. Central Time, 13:25 GMT. The crew is about an hour and 10 minutes ahead of their scheduled timeline, and currently the duo is working with MCCM, or Mission Control Moscow, to manually execute operations for the external control panel that they removed and replaced at a different operating location this morning.
I guess I should press start. Yes, that's correct. This is step 22.
Движение манипулятора остановка.
Arm in motion, stop. LED is a blinking LED that's next to roll X. Start and stop is blinking as well. Should I press and stop in step 6? Please check the coordinates and then check again after you've pressed and stop. Okay. Inaudible. You will start in 30 seconds. What step are we currently in? Is it 2-4? 2-6? No, step 26 has just been completed. Switch to step 30. Put the switch to stop. Are you sure that step 30 is completed? Because I sent the Rolex command just once. Oleg, we're currently in step 30. Well, we did not complete steps 24, 25, and 26. Oleg, you did not complete step 26? Well, I told you that I pressed on start, then I was supposed to check the F or R. So how was I supposed to do it without the command? I apologize, Oleg. I was under the impression that you had got it done. It's blinking now. Well, so we stopped at the LED in step 24 is blinking now, the roll X LED. So I press on stop, I'm pressing start now, and I'm going to start monitoring the FR frame now. Here we go. This is step 30. Oleg, we were LOS. Did you say step 30? You're switching to step 30? Yes, correct. I'm pressing on start for step 30. And I see that the coordinates along the axis are changing. I'm turning the page over. I'm now in step 3-1, actually 3-2. The LED, the roll LED is blinking for -X. And start, stop LED is blinking, pressing on stop for step 3-4. Is that correct? Yes.
Нажали стоп. Свет идет погас рядом с крем roll.
Stop selected. The roll LED is not illuminated. And the switch for step 36 should be moved up. Up.
Заморгал.
It's blinking now.
И старт-стоп заморгал.
Start, stop is blinking as well. And I'm pressing on start for step 39. Your go.
Выдал старт на 39-м.
Start selected for step 39. Era in motion, and then it stops standing by for the motion to stop. It's dark and I can see it well. I'm not sure if it's moving or not.
Он по сантиметру двигается, это вообще сложно отследить.
It is moving in 1 centimeter increments, so it's really hard to distinguish that. Correct. The LED is illuminating, and start-stop LED is blinking. Pressing on start-stop for the next step.
Нажал.
It's completed.
По 45-му свет идет, опять моргает.
For step 4-5.
The duo is currently in orbital nighttime, flying 264 statute miles above Madagascar.
It is selected now.
Так, по 49-му крем roll.
For step 4-9.
Oleg Artemiev is currently working with MCCM, or Mission Control Moscow, to configure and start up the control panel for the European robotic arm.
Так, 50-й прошел, 51-й.
All right, 50, 51. In 52, I'm supposed to press on start. Start selected for step 5-2.
Так, 53-й прошли, 54-й моргает.
Step 53, 54. Roll LED is blinking, start stop is blinking, and for step 56, I'm pressing on stop. Your go.
Выдал старт, стоп, 57-м.
It is completed. For step 5-6, LEDs are not illuminated. And the switch should be in, let me check.
Рабочий у нас в рабочем.
It should be in operating mode. And I guess we need to move it to standby. Is that correct? Yes, standby. Okay, switching it to standby.
Перевели в стендбай.
It is now in standby.
Сейчас готовь шпаргалку инициализации.
The LED is illuminated. And
на внешней шине.
Please make sure that cue card is handy.
Здесь на земле и по команде.
Inaudible.
Делайте что-нибудь.
Лек, все, мы готовы переводить.
Oleg, we are ready to switch it to the required position.
Готовы переводить на внешнюю шину.
Switch it to external.
Достаю шпаргалку.
Okay, I'm getting my cue card for now.
Денис, как дела?
Denise, how is it going? Going well. Did you put it back?
Пойдешь тоже на стрелу. Тут недолго осталось с пультом. Я их два ряда поставил.
No, actually, I put two of them together.
Сейчас будет движение манипулятора, так что в его сторону...
Get ready for ear motion. Okay. Okay, so should we keep the cue card open? Well, actually, Oleg, we're ready to execute the cue card steps. Copy? Copy that. So what should we do next? What step in the cue card? Is it the EMMI initialization on the external bus? Correct. Should I turn off the control panel?
Да. Надо выключить пульт, а потом включить.
Affirmative.
Команду reset.
Turn it off and turn it back on to avoid sending the command. Okay, copy that. I'll put it in work now. I'm turning on the control panel. It is off now. LEDs are not illuminated. And am I turning it back on now, or should I wait? Yes. Say again?
Так, 3, включаем питание обратно.
Step 3, power to off, OFF. Okay, it is off now, and the LED is off.
Display меню, автоменю, меню конфигурация EMI.
Moscow is inaudible. External bus configuration, step 11. Switch to required position for step 11. Copy. And stop is confirmed. Selecting languages.
Да, шаг 13, тумблер старт.
Step 13. Switch bus selection confirmed. Stop.
Да, шаг 15, стоп.
Step 15. Stop. Inaudible start.
Шаг 17, да, старт.
Yes, start for step 17. Okay, moving on. Update menu start. Is that correct?
Да, шаг 19, старт.
This is step 19. Yes, that's correct. And press start for step 19. LEDs are illuminated. Regular data parameters on the display for EMMI 1 English, that's confirmed. For step 2121. Step 22, done. For step 23, please move the start-stop switch to start. Copy start. And the start selection is confirmed. All LEDs are illuminated except the LED inaudible. Yes, this one is not on.
Шаг 26. Тумблер старт-стоп в положении стоп.
Step 26. Please move the start-stop switch to stop. Stop selection confirmed. Emergency should be moved to the lower position and moving it down per step 28. Yes, that's correct. Down first, and now it's saying that I should release it for step 30, step 30. Yes, move it up. And the LEDs behind the panel, the caterpillar. CPC LED is illuminated. Okay, well, this completes the steps in my cue card. Yes, Oleg, you're done with this procedure. Now we will stand by for a go to continue ERA activities. Okay.
У тебя на дисплеях параметры должны появиться координаты.
Also, Oleg, you should see all the coordinates in your displays now. This is specifically display parameters. Yes, I see that.
Олег, можно переводить в режим хранения.
Okay, Oleg, you're going to switch it to still configuration. And first of all, make sure that the brightness switch, the switch is moved to. Okay, stand by. Oleg, stand by. What mode do you see on the mode field? Let me check. I see an asterisk SB OPGR.
Все, тогда переводим, да, в режим хранения.
Okay, Oleg, in that case, you're going to put it to still config and make sure that you move the switch 2 times to move it down 2 times. Okay, that's done now. And what I have left here is the power LED. Did you copy? Yes, copy all. Should I close it out? Yes, you're done with this activity. You can close out. Oleg,
Да.
go ahead.
Ну, мы после того, как закрыли пульт, да.
So after you close it all off, please make sure that you extend the slack of the adjustable tether. Make sure that the control panel is not rotating. And also, once again, let's figure out where it would be best to route the translation path using the gap spanners.
Ну, тут один фал без подтяга.
So I only see one adjustable length tether here, and then the other one is fully retracted. Okay, so Oleg, let's assess the best configuration for the new translation path. Okay, let's give it a try. Actually, an adjustable tether is attached to my ring. This is Denise. Okay, so I guess we need to figure something out.
If you're just joining us, we are 4 hours and 32 minutes into the Russian Spacewalk 54A, where two cosmonauts, Oleg Artemyev and Denis Matveyev, ventured outside of the hatch at 8:25 a.m. Central Time, 13:25 GMT. The duo then transfers to their work site outside of the Nayoka module, where they were completing work on the European robotic arm. Currently in the orbital nighttime, the duo is heading back to a previous work site where they were adding in gap spanners. They had a little bit of trouble with the gap spanners and moved on, and now they're heading back because they have completed multiple tasks ahead of schedule. The duo is currently about an hour above they're about an hour ahead of their timeline, are going back to complete the gap spanners.
I don't know if I can reach it with this one. I'm going to try.
So far, the duo have installed work platforms on Nayoka. They also relocated the European robotic arm external control panel. They just completed testing the European robotic arm in effector grasp capability. They work with Mission Control Moscow to configure as well as start up that control panel. Again, they're currently traversing back to a work site where they will install some gap spanners.
Okay, so I reached for 109.
Тогда, наверное, удобнее будет нам ходить. Тогда переходи на такелажный узел стрелы.
In this case, it would be better to go around.
Надо дотянуть два болта барашка на блок.
Once you get to Strela, you will need to tighten two wing nuts. Okay.
Олег, Денис.
Oleg, Denis, go ahead.
Нам дали добро идти на ФГБ. Работать.
You are go to translate to FGB for ops. Okay. So what about this tether? Do we leave it at the panel? Yes. Equipment tethers are to be left. No, I'm talking about a different one. The one for translation.
Просто один, как мы планировали изначально по проектной.
Well,
а второй, как ты проложил, который, чтобы удобнее было.
One is going to be configured per our original design, and the second one will be configured per your proposal. Okay, understand. I think I need the cue card now.
Через 4 минуты будет солнышко.
In 4 minutes, we will have inaudible. Copy.
Да, что тут, подкрутить надо, да? Да, там 2 винта.
Inaudible.
Один внизу.
So we need to do this one.
А сколько крутиться здесь?
So how many turns?
Полоборота достаточно ключом. Много не надо.
Half a rev is sufficient.
Переворота получилось.
Well, I think I'm getting 4 revs.
Это да, это полоборота.
Okay, on this one, indeed, it took only half a rev.
If you're just joining us, we're 4 hours and 47 minutes into today's task, a Russian spacewalk, Russian spacewalk 54A.
All going this way.
Expedition 67 Commander Oleg Artemyev and Flight Engineer Denis Matveyev, both of Roscosmos, exited the station face-spacing Poisk module at 8:25 a.m. Central Time, 13:25 GMT.
On FGB, we will.
Artemyev is wearing the Orlan suit with the red stripes. Matveyev is wearing the Russian Orlan suit with blue stripes.
We leave the bag on SU.
Today's spacewalk will complete unfinished tasks from a spacewalk in August, which was cut short because of Artemyev's suit showing abnormal battery readings about 2 hours and 17 minutes into that spacewalk. During the previous spacewalk, Artemyev and Matveyev completed the installation of a pair of cameras on the arm, that's the European robotic arm, and removed parts attached to the arm's end effector before the spacewalk ended.
Items at the operator post.
So far today, the duo has installed a work platform on the Nyoka module, relocated the European robotic arm external control panel. They have adjusted and tested the European robotic arm's end effector grasp capability, and they are currently going back to a task that put in grapple. They are going back to a task to put in gap extenders.
Anvil. Okay, let's start.
Сейчас у нас порядка, наверное, 6-7 минут будет такая плохая связь.
Oleg, we're going to have Raticom for about 6 to 7 minutes. Okay, we're moving to gap spanner. Leave crew back there. Affirmative. And the rings will be left on S2. Okay, I'm going to translate to where we will be leaving the rings. Okay, and I will go take care of the crew log bag. Inaudible. Did you test the ring? Not yet. Okay, did you remove the large one from the crew lock? Yes. I was gonna hand you the other handle. Oh, you want to attach it to the new one? I'll put it in this place. Oh, yeah, right. Artem, are you there? Yes. It's just that the comm is really bad. Shall we bring the second retainer? Negative. Leave retainer in crew lock bag and leave crew lock bag on gap spanner. Inaudible. And the retainer will be accessible.
Меня услышали?
Did you copy? Please say again.
Я говорю то, что блокиратор оставляем в крылок-бэге.
Retainer will be left in the crew lock bag. Crew lock bag will be left at gap spanner between MRM2 and FGB. Oh, I thought we were going to use a different one. No, we're going to do it as we talked yesterday, just like you proposed. Inaudible.
Нет, нет, мы идем на стрелу.
No, we're going on Strela. Okay.
If you're just joining us, we are 4 hours and 55 minutes into today's Russian Spacewalk 45A. You're currently seeing Oleg Artemiev and Denis Matveyev of Roscosmos. Artemiev is wearing the Orlan suit with the red stripes, while Denis Matveyev is wearing the Orlan suit with the blue stripes. They are currently tying down a bundle of launch restraints and MLI, or multi-layered insulation, that they retrieved earlier today. They're tying it down to the end of one of the Straya booms.
Let's try this. Okay, this ring is secure. Okay. Okay. You're a little bit in the way. All right, let me grab the short one. So I can attach this one. Yes, right here, and I am moving away. Do you want to reattach this one? I think so. Oh, this is better. Excellent. That's it. That's a lot better. Oh, I did a little tumble here. Okay, here comes the second one. Do you want me to hand it to you? Yes, please. Okay, you can give it to me. Ready? Yes. All right, here it comes. Very good. Here. Олег? Yes.
Выходы у нас, когда адаптер поддона вы откручивали, там я сказал, что была нештатная ситуация с замком год назад. Вот это как раз тем самым замком, который перед твоими глазами.
Олег, did you copy our call about the tray opening incorrectly, and this is where we need this latch? Inaudible. So this one is not good. Yes, we have a feeding fly out of there. But you don't have to pause for it. So now it cannot be removed? Yes, we decided to leave it there forever. I could try and maybe wiggle it around, maybe make a few turns.
После того, как поставим блокиратор, об этом подумаем.
Let's think about this after we are done with the retainer. Okay. Inaudible. That's not easy. Can you hold this? Okay. Please watch this hook. Or actually, let me release it and you give it a pull. Okay, excellent. So now we have to secure it on something. Maybe there's a restraint point in a drum. Sure, why not? Okay, now let me get the second tether. Are you putting it on? So I think you attached the short one. No, I haven't. So you want me to hand you the short one? Hold on a little bit. And now the second one. Okay, wait a little. Let me take this out of here.
Поаккуратнее ногами, ты задеваешь
Okay, now
кабелем СС.
now you can hand it to me. Okay, watch out. Your legs are impacting the cable holders. Okay, I'll try to be careful. Okay, now we're moving on to the gap spanner. And on to FGB. Yes.
Dennis, you need my help? Maybe hand me a hook. It's the short one. Here it is. This way. I'm a bit stuck. Like this. Is it? Almost. And these cables just keep translating. All done. Just waiting for you. Make sure the camera is in place.
Олег.
Oleg? Yes. Yes, Kennedy.
Уже давно выключил. По нашим понятиям, 35 минут.
I understand that you turned off the pump some time ago. It has been 35 minutes. And how are you doing? Well, okay, I just turned it on again. And
Если будет, потом как
just
охлаждение уже.
turn it off again. So make sure you don't get too warm. Well, I kind of got heated up now, so it feels good. But make sure it's not too warm because it will be uncomfortable for you to cool off. So we have not bothered you, but it's been some time already. So, okay, I'm saving the battery.
обоих работает отлично в этот раз.
All your batteries, both for both of you, are operating excellently. Okay, then I can use the pump. We have a wire tie, and we've been lacking some, so let's gather all the wire ties we can. Sure. There's a barrier or something. Like a cord. Unintelligible. Some handrail.
If you're just joining us, we are 5 hours and 14 minutes into a Russian spacewalk, Spacewalk 54A. Expedition 67 Commander Oleg Artemyev and Flight Engineer Denis Matveyev have been outside of the International Space Station working on upgrades to the European robotic arm. One of the primary tasks that was completed this morning was the relocation of external control panel for the European robotic arm, as well as testing out a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. The duo has been about 50 minutes to an hour ahead of their scheduled timeline pretty much all day, and they are currently looking to work towards some of the get-ahead tasks.
Олег, Денис.
Oleg, Dennis?
Да.
Yes.
Произошла стыковка манипулятора, пока мы ходили.
So while we were translating,
Стекло чистое, чище не бывает.
and the arm got connected and burst and just cleanly and perfectly. Very good. So our work was not in vain.
Да. Так, тут здесь как-то... Знаете, поручень могу точнее, могу дать. Нет,
I will need to move the gap spanner closer. Let me try.
Так, давайте вот разминчик.
Give me your hook. That's not a very convenient translation path.
Так, раз.
Here.
Ну давай сейчас. Нахлёстом сейчас. Давай. Ой. Ой. Подожди. Ай.
Just a minute. Temporarily here.
Так, ну все, мы уже к грузовой стреле подошли, да?
We are already close to Strela.
Когда будет возможность у тебя, включи, пожалуйста, камеру Ерку.
When possible, please activate ERCA camera.
Ты кому?
Are you talking to whom?
Мне, наверное.
Probably
Тебе,
me. Yes, yeah. Mine is on.
Ерка. И посмотри на свои скафандровые карабины, они нормально?
And check your hooks. Make sure they're good well. Look well. Yes.
Так, Ерку надо включить.
Turn on ERCA. Should be on.
Так, ну что ты хотел сказать?
So, what did you want to say about the hooks? Just make sure they are locked well. I just want to make sure. Yes, I turned on ERCA.
If you're just joining us, we are 5 hours and 20 minutes into a Russian EVA 54A. We're currently in a brief handover between satellites, and we'll have those views of the duo outside the space station back to you briefly. The crew has been about 50 minutes ahead of their timeline for most of the day, and they are looking to do some get-ahead tests involving the Straya boom.
Good.
The first one is looking to extend from the FGB, or the functional cargo block, the Zarya module, to the Poisk module.
Так, за этот можно, да, тут? За серый? Я не знаю, вы не уверен, что...
Shall I connect here? I think Artemis that would be better. Oh, you can also use metal handles.
Один на тряпочку, а другой на...
So put one hook on a soft gas spanner and the other one on metal. All right.
Олег.
Alec.
Да.
Yes.
Проверь, пожалуйста, страховку на стреле. Денис, а ты...
Check attachment and transportation should not be secured this way. Yes, I am rehooking it.
Можно на стреле только за лееры.
On Stellar only
Жесткие металлические поручни.
the metal handles
Страховочные фалы, которые имеются...
can be used. Don't use the transportation tellers. Okay.
Денис, можешь проверить, пожалуйста, да, страховки СТУ, чтобы она...
Dennis, can you check the side of BTU connection?
Фал сам...
Да, вот я его сейчас перескакиваю.
Yes, I'm rehooking the teller here.
Так, СТУ застраховано вот сюда, за...
It has been secured to the handrail. And this is Strela itself. Shall I connect to handrail, rail 1, and to the gap spanner 1? Yes. Use the first section of the gap span. And use a long tether for that. All right. I have the long one detached. Attached now, and the short one to the handle. Now I can see where Strela itself is connected.
Давай.
I am ready to take out Strela here. It goes this way with all the links. Check, make sure that your tether is not getting in between Strela tethers. Okay. And I'm connecting it here to the handle as well.
Денис, этот фал ты снял?
Dennis, this tether is from the foot restraint, right? Yes, it went through the foot restraint to the handle. Was it in a module originally? Yes.
Стрела была зафиксирована не фалом переменной длины.
Connecting to the handle first. And this is the fixed length tether. How about moving it through the adapter and attach it to the bracket of the foot restraint, and on the other side from the handle of Strela or the gap spanner there. Okay. Okay, so push this through the hand foot restraint, and here it goes on top. Okay, now it is attached. Ready.
А фал переменной длины вообще есть у такелажа?
And adjustable, any adjustable tether in the area? No, I don't see any other one.
Стрела, в общем, расфиксирована, да?
So, Strela
От модуля.
is released from the module, right? Yeah, I don't see it holding it to the module anyway. And ERA is interfering with the structure. No, it's not.
Денис,
Dennis,
знаешь как?
If you're just joining us, we're 5 hours and 30 minutes into Russian EVA, or Russian Spacewalk 54A. Oleg Artemiev and Denis Matveyev have been outside the International Space Station Russian segment doing upgrades to the European robotic arm. The primary objectives have been completed of the spacewalk. Those primary objectives include the relocation of the external control panel for the European robotic arm, as well as completing tests that tested the grappling mechanism of the European robotic arm. So far today, the crew has installed a platform with adapters onto the Naoka module. They have transferred the control panel to the base point of the Naoka module. They have installed 2 gap spanners. They have also positioned end effector 2 and end effector 1. They removed a launch restraint that was on the end of end effector 1. They've also tested the operations of the control panel. They have also completed the installation of retainer on the Straya Boom 1. They are now currently into get-aheads. The crew has been working ahead of their timeline about 50 minutes, and they're now looking to do the extension from the Zarya module to the Poise module from the Straya 2 boom.
Now checking. Installed with a long tether. One hook to the ring and the other to the base of Strela.
The duo is currently translating to the Straya 2 boom end effector using the translation ring. Once they get there, they are going to try to secure the translation ring onto the Straya 2 boom end effector.
There is another tether that can be cinched, and that is ring to ring. It looks like there are 3 tethers. One retractable, and one is long. Use that second one. Attach it to inaudible. Say again, to the handle. To the handle. If there is an eye bolt there. Yes. Okay, so just get it to the handle. Just where the retainer is. There is a thick ring in the end that can be used to secure it. I see. Okay, got it. To the ring, one to the ring and the other to the handle. That's true? Now let's check. So one tether to the thick ring and the handle, and looks like we have 2 tethers to the base of Strela. And that tether that is connected to the foot restraint. Yes. If we figured it out with all the tethers, then We just need to get confirmation and keep going. Yes. And when do we have eclipse? In 10.5 minutes, eclipse.
Night pass coming up in 10 to 15 minutes, 10.5 minutes. Are you sure we're not going to be at night pass? No, go ahead and get started. Go ahead and lift it in pitch direction. Copy, pitch. Okay, it's unlocked.
И вращаем со скоростью 1 оборот за 2-3 секунды.
And start spinning it with the following speed, 1 to 2 turns every 1 to 2 seconds. Make sure that the Strela boom is freely moving away from the module. Yes, nothing should be holding it.
Денис, еще к тебе такая просьба развернуться.
Also, Denise, can you please turn to the side now and monitor FGB solar arrays and plane 3. And also we're recommending that you turn on the inaudible. Well, actually, no, I can't do that because I need to be holding on to something. Okay, so the solar arrays are nearby, but it's moving nominally. Can you see it? Yes, we're watching it all, guys. And there is some kind of a inaudible. Oleg, what was that? I'm saying that there is a loose screw here. Is that the way it is supposed to be? Is the camera on now? Yes, they are. Okay, if you look in the middle of the frame, you can see the screw that I'm referring to. I'm not sure what exactly it is supposed to hold. Oleg, when you're done with your current activity, please make sure that you take photographs or make a video. Okay, sounds good. So it should be lifted in the vertical direction. Well, and it should not be precisely vertical, but yes, move it up. Dennis, how are you? Well, I'm doing well. And what is it? This looks like fishing. What exactly are we going to catch? Well, whatever we catch will be good enough. This is the largest spinning in the world. Dennis, Oleg, if you're going to move past the solar arrays, when you start turning in your direction, please report.
5 hours and 40 minutes into the Russian Spacewalk 54A, Oleg Artemyev and Denis Matveyev have completed all primary tasks, including relocation of a control panel for the European robotic arm, as well as testing that arm and making sure the grappling fixture worked properly. They are now moved on to the get-ahead tasks. They are looking to currently extend the Australia 2 boom from the Zarya module to the Poise module.
So, I hope it's not swinging too much. No, it's just fine. It's moving very slowly, smoothly. Okay. Do you think we're gonna go past the solar array when turning?
Денис, как слышно?
Oleg, Denis, how do you read me?
Денис?
Oleg, Denis, how do you copy?
Олег, Денис, как слышно?
Oleg, Denis, how do you read me? So how is it going? It's going well. Inaudible.
Как слышно?
How do you read me, guys? Look over here. No, I think it's all nominal with this solar array. So is it going to move underneath the batteries then, Artyom? How do you read me, guys? This is Artyom. Yes, loud and clear now. We can hear you now. Yes, the comm on our end is very intermittent. Okay, so we're going to lift it up now along the yaw direction. Yes, on the right. Well, actually, I think you need to move a bit more. So the Strela boom is supposed to move underneath the arrays. Is that correct? No, over the arrays, over FGB solar array. And between the antennas along plane 3. Between the antennas installed along plane 3. Correct. So basically the Strela will be between the arrays and the antennas on plane 3. Yes, that's what I'm saying, underneath the arrays. So, okay, from your vantage point, Oleg, that would be underneath the arrays. I got it now. And we're coming up on a night pass. Yes, 20 seconds to eclipse. But keep going, keep monitoring.
Обязательно наблюдайте солнечную батарею.
Make sure you're watching closely the solar arrays and make sure that it is moving away safely.
Так. Ну что, ты уже как свечка или как? Как то?
Well, so is it aligned? Is it all straight now? As straight as a candle?
Ну, в целом, можно еще чуть полевее, наверное.
Well, I'm not sure yet, but I think that you could move it to the left. What about pitch? Pitch is good. Okay.
Currently in an orbital nighttime, the crew and the International Space Station are flying 265 statute miles off the coast of Africa over the South Atlantic Ocean.
Олег, Денис, меня слышно?
Oleg, Denise, how do you read me? Oleg, Denise, how do you copy? Okay, we can hear you now. We had some minor issues with comm, and I'm now on SHSS channel. Are you still raising the Strela boom, or did you switch to the next step? Well, actually, we've raised it already, and we cannot see it that well right now. I don't think that we can raise it.
Currently in a brief handover between satellites, you are currently seeing the Russian International Mission Control Room. This is a balcony view, but we should have views of outside the station back to you shortly. We're currently seeing a helmet cam from Denis Matveyev. The crew is still doing work aheads, get ahead task, looking to extend one of the Australia Boom 2 from Zarya to the Poisk module.
roll axis, and the boom is vertical. Can you see the structure, MRM module, the solar arrays? We need to make sure that as it gets further extended, you can see it all. Well, it's in front of me. I should see it. And we're getting the video that's very dark. So that's why I wanted to clarify that with you. Well, yeah, I see it now, and I'm monitoring all the operations. I think it is clear by about 2 or 1.5 meters. Okay, that's great. Okay, it stopped. It wouldn't move to the right. Okay, let me back off. I can see it now. Oleg, please check out the safety tethers. They may be fully extended and tense, and that's why it's not moving anymore. Okay, let me check that. I don't think it's the case. Inaudible. How are you? Excellent. I can see you. this feels like climbing a fir tree. It's moving back. I see that it's moving. Okay, what is it? It wouldn't budge. Okay. Oleg, can you please check out the opposite side of the Strela? Maybe there is something in the way on that side. Okay, let me check that. Okay, I guess I'm supposed to install the retainer to close it down. Is it the correct direction? Yes. And I see that it is moved up. Inaudible. Okay, I guess it's fine. So it wouldn't move at all? Well, actually, I can try using full force. Okay, so let's try to figure out what kind of force you'd need to use here. Well, it was going just fine, and then it stopped. Okay, let me go in reverse here, using an old trick. Okay, go ahead and do about 5 turns. Okay. Do you have to use force in reverse direction? No. Okay, so I see that it's moving in the opposite direction. Denise, from your vantage point, can you tell us, are we clear of the structure of tethers or any other elements? Well, I'm actually in the straight vertical position here, so I can really say for sure. I guess that's a question for Oleg. Okay, I guess little by little it's starting to move. So how much do we have left? I guess we need, well, let's say about 30 degrees more.
If you're just joining us, we are 6 hours into today's Russian Spacewalk 54A. We're currently in an orbital nighttime as the duo Oleg Artemyev and Denis Matveyev, along with the International Space Station, fly 260 statute miles above Somalia. The crew exited the hatch from the Poise module on the space-facing side of the Poise module at 8:25 a.m. Central Time, 13:25 GMT. Oleg Artemyev is wearing a Russian Orlan spacesuit with the red stripes, while Denis Matveyev is wearing a Russian Orlan suit with the blue stripes. All primary objectives, including the relocation of an external control panel for the European robotic arm and the testing for the mechanism on the arm's grasping end effector that will facilitate and move around payloads, has been completed. Artemyev and Matveyev have been working about 50 minutes ahead of the scheduled timeline and moved on to get-ahead task.
A part of a solar array. It's or what is it?
The primary get-ahead task is the extension of the Straya Boom 2 from the Zarya module to the Poise module. The crew is currently working and facilitating the movement of that boom.
Okay, let's move some more. Okay, well, this is much better now. Oleg, do you feel anything? Well, no, I don't really feel anything right now, and I don't think that there is a hazard here. It just keeps extending.
Okay, it's going back now.
По-моему, мы уже стрелу из этого солнечную батарею.
I think we have cleared the solar array. Can you confirm? It's hard to say, but it looks like it. Let me just correct the reference. Yes, I don't see anything here. I can kind of see it. Artem, go ahead. How much is left until inaudible? 3.5 minutes.
Okay.
How much? 3.5 minutes.
3,5 минуты.
You said 3.5? 11. 1-1.
Ну что, рискнем? Давайте, потом сможешь чуть-чуть порыть, когда будет. Я там не понял, сколько у нас до конца времени. 11 минут. 11? Да.
Inaudible. Okay, so which way are we working? Pitch. Yes. Continue along the pitch direction. No need to remove. I do not see 1, 2 yet. Can only assume. The window is not illuminated. Okay, releasing it now. Okay, give it a pull. Oleg, let's wait until the installation. I think it's a good idea. Yes, the specialists are suggesting. We only have a few minutes until sunrise. Less than 8 minutes. Okay. We'll take a break.
If you're just joining us, we are 6 hours and 12 minutes into the Russian EVA, or Russian Spacewalk 54A. 2 cosmonauts exited the International Space Station, the hatch of the Poisk module at 8:25 a.m. Central Time, 13:25 GMT. We're currently in an orbital nighttime, and the crew is waiting the next 5 minutes and 57 seconds until the sun rises to finish up a get-ahead task, extending the Straya Boom 2 from the Zarya module to the Poisk module. The crew completed all primary objectives earlier this morning, and that included the relocation of an external control panel for the European robotic arm, as well as a test for the rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. So that was on the end effector, on the end of the European robotic arm. The European robotic arm, which launched last July attached to the Nyoka module, will be used to move payloads and equipment outside the Russian segment of the station, joining the Canadian-built Canadarm2 robotic arm and the Japanese arm already supporting station maintenance, operations, and research. We're currently in a brief handover between satellites, but should have those views of the crew outside working back to you shortly. You currently see a live view inside the Russian International Mission Control Room.
You're not too cold? No. Actually, warming up here. Sounds good.
Again, if you're just joining us, the crew is currently pausing on that Straya Boom extension from the Zarya module to the Poisk module until they have that sunrise. They're about 2 minutes, 50 seconds away from that sunrise. So they're just pausing right now.
Loud and clear.
Выхода из тени 3 минуты.
3 minutes until sunrise.
Как ваше самочувствие?
How are you feeling? Feeling great. Feeling good. Alex, Denise, how do you copy? Loud and clear. Still a bit of interference on the loops, but in 10 seconds, the sun is coming up, and as soon as you can see the modules, please start with your activity. Okay. Okay, the sunrise is here.
And there goes that orbital sunrise that the crew was waiting for, as the crew and the International Space Station flew 262 statute miles above Mongolia. We're now looking for the crew to finish up that get-ahead task where they are extending the Straya Boom 2 from the Zarya module to the Poisk module.
Where we are sending it? In pitch, along the pitch direction. Okay, it seems to be going pretty well. I think it's clearing all the structure. Can you turn your camera on maybe? So, and keep it on? You can set it on your chest. Okay. Okay. Going nicely. I think it cleared by 50 centimeters. You said 50? Yes, 50 centimeters is okay. All right. Oleg, Denise, how are you copying? Loud and clear. I had to get in another headset because I thought the issue was my headset. Comm was so bad. Did it work? Well, you heard me, right? When was it last time we worked with Strela? Well, right now we are doing 54A, EVA 54A. And last time the Strela was operated was on EVA 45A, so reverse order of digits, about 4 years ago. I understand. It's just that it is tight for a while, and then it goes real easy. It is possible that some wires have frozen. Okay. Watch out with legs. Yes, I'm trying to get under this one. Is this going to be enough for you to reach? Yes. And now extend, right? Yes. Okay, we'll ask Artem. We'll let Artem know when he is on the loop. Oleg, why did you take the panel out? Say again. Why did you take the tool out? I didn't take it out. It flew out and started flying around. Oh, I see. Copy that. Velcro isn't strong enough. The umbilical is pushing it off the Velcro. Okay, so are we ready to extend? Artem, we were waiting for your go. Okay, guys, we actually need to pick up the pace. Inaudible. Okay, so we start extending. Yes, go to extend the boom. After you aim it at the MRM. Well, we are not aiming at the MRM yet. Do you want us to aim it at the MRM right away? Yes. This way, the extension will take you to MRM. First, you have to align the pitch angle to point at MRM2 and then start extending, because otherwise it will be more difficult to lock it in the proper position.
If you're just joining us, we are 6 hours and 30 minutes into today's Russian spacewalk 54A.
Can you descend lower? No, the other
Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev, both of Roscosmos, exited the space station space-facing Poisk module. The primary objectives have been completed for today, which included the relocation of external control panel for the European robotic arm, as well as testing out one of the rigidizing mechanisms on the arm that will be used to facilitate the grasping of payloads. The duo are currently extending the Straya Boom 2 from the Zarya module to the Poisk module. We currently have motion and movement from one module to the next.
It looks like we're not going to be able to point it at the MRM. Let's try extension first. Okay, Oleg. You can start with the extension, point it to the right and above EV hatch to where the ring is installed. That's where I was pointing. Okay, extending the boom now. Do you see it? Yes. Oleg, is your glisser on? Affirmative. Okay. Okay, passing the AKS antenna. Copy.
Так. Получается, мы ниже. Надо тебя поднять.
I think you are too low when we need to raise you up. Okay, I'm not moving.
Так, теперь я тебя должен вверх.
So now I have to move you up.
Так.
Okay.
Инерционная стрела.
This boom has a lot of inertia.
Так, теперь опять выдвигаемся. Выдвигается? Да.
You see it? Yes.
Так, теперь я даже повернуться лицом.
Okay, let me turn around so I'm facing it.
Dennis, when you get close to MRM2, in a grapple fixture, probably the foot restraint will need to be turned. I will try, or maybe you can do it now. Okay, I did it just now. Thank you.
Так, Олег, надо подогнуть.
Alec, now you need to go down on pitch down above progress. Okay, pitch down.
Да? Да. И влево, да?
And to the left, right? Probably.
Да, влево не надо. Вот.
No, not to the left, just down for now.
Хотя да, надо будет и влево.
No, a bit to the left as well.
Что, вниз идет? Да, там, а ты в ту сторону?
You're going down.
Не, вниз правильно надо, да?
That is correct.
Так, подожди, а я вижу, что ты уже мимо едешь.
But I see you're passing by. No. Probably need to go up now.
Ты поближе просто.
Well, you are closer. Better view.
Просто вот это, о. Просто вот этот поручень 6033.
This is 163. It is under the target, and there are 3 cylinders there. Yes.
Так, ну что, выдвигаю или? Да, выдвигаю.
Should I keep extending? Yes. If later, at other EVAs, you will be removing the restraint from the end effector, maybe it will need to be rotated. It is being rotated easily at this time. Okay. Is it extending? Yes, it is. Please stop for now. Maybe retainer can be moved to the other side, a little bit up. Okay? Okay, it's up. Are you ready? Yes. I believe it needs to be lower. You have a better view. Yes, 1 meter lower. Okay? Some more? Yes, some more. Like here? Yes. Maybe a bit lower. Any more? Yes. And you're to the left. Okay? And then a bit lower, pitch down. You see the boom with some white on it. This is where trail is aiming at right now. Any more? You're to the left. Stand by. Actually, the mobile...
If you're just joining us, we're 6 hours and 42 minutes into today's 253rd EVA in support of ISS assembly, maintenance, and upgrades. 2 cosmonauts ventured outside of the International Space Station, the POIS module, at 8:25 a.m. Central Time, 13:25 GMT. Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev are currently working on get-ahead tests where they will extend the Straya Boom 2 from the Zarya module to the POIS module. The duo has completed the primary objectives of the day, which included the relocation of external control panels for the European robotic arm, as well as a test that tested the rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads.
To release the link. Okay, Let's try. So not to the left. Let's try to pitch, and then it would be possible to move a little bit left. Yes. So now going up. Yes, going up.
On your screen, you see a great view of the Straya boom as well as both cosmonauts. We see Oleg Artemiev in the Orlan suit with the red stripe, and we see Denis Matveyev in the Orlan suit with the blue stripes. Artemiev is cranking to move the Straya boom to the Poise module, as we have Denis Matveyev at the end trying to do the connection.
Is it extending? Yes.
The duo moved about 50 minutes ahead of their planned schedule, which allowed for them to have time to get to the get-ahead task.
Shifting right again.
After the completion of the extension from the Straya boom from Zarya to the Poise module, the duo will head back to grab that bundle of protective coverings and the launch restraint rings, and they're going to tie those down. After that, the crew will look to head back inside, where we conclude today's EVA.
Okay, keep extending then, and then I will hold it and then connect to the handrail. Okay, extending. Stop. I would try to secure it. So there are hooks in the crew lock bag. Make sure to use it. Yes. They keep extending. No, hold on. Let me secure it against the handrail. Dennis, please return this hook and take another one. The one that is connected to the handle, and this one return to the eye bolt. Okay. Okay, attach it to 6033. Let me tighten it. Okay. Attach to 6033 and tighten. And how to get off Strela now? Check the 220 tool is not flying around, not hanging and try to remove the handle. If it is removing easy, then we are good and we will install the retainer. If not, we're not going to install the retainer.
Так, выдвигать что-нибудь или сдвигать?
Shall I extend or remove? No, not extend anymore. It looks good. Can you go down, pitch down? Just a little bit. Very little. Go ahead.
Все.
Stop. Okay then.
Как со стрелой куда уходить?
And how to get off Strela now?
Нет, она трутине этот.
Artem, it is not actually giving up by handle. Maybe I should use the tool and kind of got stuck. Then let's move down through Strela. Get the crew log bag.
Да, но спуститься мне надо полстрелы пройти.
Well, I'll have to go through half of Strela. I think you'll need to get to the other side of Strela. Towards 6033 handrail. There are circular handrails. And this is where the crew log bags are. Alec? Yes. And about the tool, is it okay? Is it in place? Attached? Yes, it's attached. Okay, now continue movement. I mean, move towards Dennis. We are going towards easy hatch now. Okay.
Олег. Да.
Oleg? Yes.
У тебя за минут 40 насос отключен.
Погрелся.
How's your thermal condition? For about 40 minutes you had the pump going. Yes, I did get warmed up. I turned it on. I copy.
Время назад прошло сообщение, патрон ограничен, да? Да, да.
Also, battery limit message came on. Yes, I know, and that is good. That is normal. Dennis, before attaching one of the crew log bags, close the flap first. Okay, let me get that close. The crew look back is attached to me. Before moving, Alec, check. We had 2 tethers on tail. Both will need to be removed from trailer boom. No, don't take it with you. Just keep them in a stow. Okay.
Так, а по кольцевой можно, да, к другому люку перейти?
And
If you're just joining us, we are 6 hours and 55 minutes into Russian Spacewalk 54A. Oleg Artemyev and Denis Matveyev, both of Roscosmos, exited the station's space-facing Poise module at 8:25 a.m. Central Time, 13:25 GMT. They completed their primary task or objectives for the spacewalk, which was to relocate an external control panel for the European robotic arm from one operating area to another, and test the rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. Being ahead of their timeline about 50 minutes all day, the duo was able to move ahead to the get-ahead task, which currently they are completing. That task is the extension of one Straya Boom 2 from the Zarya module to the Poise module. We just had views of Oleg Artemyev in the Orlan suit with the red stripes as he was translating from the Straya Boom 2 out from Zarya to the Poise module, translating on the using the translation ring. Once he's to the end of the Straya Boom 2 end effector, he will secure that translation ring.
why do we need to take 2 tethers? Maybe 1 is enough.
The last task of the day will be to get that bundle, the bundle of protective coverings and launch restraints that was gathered earlier this morning, and they're going to tie it down to where it's currently positioned on that Straya Boom 1. After that, the crew will then head back inside, and that will conclude today's spacewalk.
Okay.
Так. Денис, ты ушел уже? Да, я что-то убежал. Так. Что тут надо было сделать?
What else did I need to do?
Олег, смотри,
Alec. 1 tether
пол с подтягом на СТУ.
on STU that needs to be connected to the end effector, and a fixed length will need to go through the handle of Strela adapter and attach to the base point. Okay, stop. Don't give me too much information. Give me little by little. So, retractable. Where do I put it? Attach it to Strela handle. Which handle? Or on the last link? Yes. I copy. Okay. Oleg?
Now 7 hours into today's spacewalk, Russian spacewalk 54A, we currently see Oleg Artemyev in that Orlan suit with the red stripes. He's currently securing that translation ring at the end of the end effector on the Strayaboom 2.
Towards the solar array of the service module. No, it will be on my right. Okay, I'm looking at the solar array with them.
На другую, извини, на другую. Назад надо, на 180 градусов.
No, 180 degrees back. 180, the other one, yes.
Теперь тебе надо пониже, на солнечную батарею Сэма.
Now a little lower.
В сторону ног своих.
Towards your feet. This way?
Да.
Yes.
Наблюдаешь объект?
Is there an object there?
Объект над солнечной, в районе солнечной батареи.
Above solar array, there is an object. Can you see this? What am I looking for? I don't understand what you are saying.
Над дальним концом солнечной батареи. Там мы наблюдаем через телекамеру некий объект.
So there is at the end of the solar array. It looks like there is an object. It's like a little square, right? Or is it antenna you are looking at? No, it looks like a free flyer.
Олег, давай не будем тратить время.
Okay, don't waste time. No, I don't see anything. Let's go back. Okay, the first hook is attached to the handle that we removed earlier, and the second.
Второй карабин, второй фал мы.
The second tether, the fixed length via adapter handle to the end effector. Through the adapter handle.
Так, ручка адаптера, это... Адаптер-то опущен.
Adapter is lowered, the one with the wire tie. Yeah, through that. Copy.
Денис, как слышно?
How do you read me? I read you loud and clear. You're already next to EV hatch. I have two requests. First, check if inaudible is available on you. Yes, it is.
Принято.
Copy.
Второй тогда момент. Ты застраховал стартовые кольца с помощью проволочного фиксатора?
And the rings are on
еще проволочным фиксатором.
the wire ties. You can use one of the wire ties from the kit. Do you want me to attach it? Yeah, just make sure attach it to the handle of Strela boom so that they are not flapping around.
Так, за
to attach to the handle of their base adapter. Yes. No, just tighten through the handle and attach to Strela handle. This is where the previous tether was. This will be an attachment to the restraint of the adapter to Strela. No, we already have this done. Okay, good. And what about restraint itself? Yeah, this is the one used to be done.
So, Oleg, basically one of the hooks is secured on the handle that's at the grapple fixture. Yes, correct. And then the second one should go through the adapter handle and should be then installed or secured on the foot restraint bracket. Copy that. Okay, great. And that's in work. Oleg, and then please start translating towards the EV hatch. Denise, how is it going? Well, I'm moving towards the module now. So I switch to the circular handrail, and basically I just pass the modules, and it's not that convenient.
If you're just joining us, we are 7 hours and 8 minutes into Russian Spacewalk 54A, where Oleg Artemyev and Denis Matveyev have been outside the International Space Station completing upgrades for the European robotic arm, which include the relocation of a external control panel for the European robotic arm, moving it from one spot to the other. Also testing a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. Currently on your screen, you see Artemyev in the red stripes, and you see actually Denis Matveyev is a little bit out of view right now. He is wearing an Orlan suit with a blue stripe. Currently, you see the securing of the translation ring at the end of the Strela Boom 2 with Artemyev, and you should see an LFM ring or a launch fixture mechanism ring that Denis Matveyev has and will stow at the end of the Strela Boom 1. He will use wire ties to secure that to the Strela Boom 1 before the crew heads back inside the Poise module. After closing of the hatch, that will end today's spacewalk.
Denise, go ahead. So while we're waiting for Oleg, and since you are at the EV hatch now, why don't we go ahead and do the audit with you? Sounds good. OTA, swing arm, tool caddy, and consumables. Good. OTA, swing arm, left swing arm. Here, tool caddy is also here, and the trash bag, I have that as well. Glisser unit. I've got that one. Glisser is here. Copy. And the tool caddy has the ERA tool 6, correct. And now red for Glisser unit tethering, correct. And then another red for inaudible. It is here. And what about unattached small red? Small red. Let me check it. Yes, I have it. And also a small large red as well. So one small one and another one that's small and large. Yes, with the handle. Copy. So let's check the crew log bags since you have them. Well, actually, they're inside already. Okay, well, they're inside. We're not going to take them out. I guess we can do that at sublimator drying. So we did not retrieve the torque wrenches. So actually, we did retrieve one during today's ops. Okay, the cutter was not used. No cutter. And we only have one retainer. Yes, one of them is inside. Okay. And inaudible should be inside. It is inside the crew log bag. Okay, copy. And the cue cords are in the bag as well, correct? Well, yes, that's the most valuable thing that we've got. Copy. Oleg, please keep moving towards the EV hatch. It's time for you to go back in. Okay, sounds good. While you're catching a break, we can also do the equipment audit for you. Let's do it. So, okay, here it goes. OTA, swing arm, tool caddy. Okay, I've got all of that. OTA, swing arm, tool caddy. What about Glisser unit? Yes, I've got the Glisser M right here. ERA tool number 6. Do you have it? Yes. What about reds? You should have a small red. I've got that one to tether the Glisser unit. Affirmative. I have that. Do you have the red for ERA tool number 6? Red for tool 6? Red for ERA 6 tool. So what is it? Okay, this is the Phillips type tool. Okay, I got it. Yes, I have it here. Another red for tethering ratchet wrench. Yes, I've got that one. And one more small red for tethering equipment, and another red that's longer, a large red. Okay. Copy. Also, you had 2 USOS cameras Where are they? I have one of them, and then the other one is inside. Okay, copy that. Oleg, are you close to the EV hatch? I'm on my way.
If you're just joining us, we're 7 hours and 16 minutes into today's Russian Spacewalk 54A. Oleg Artemyev and Denis Matveyev have completed all primary tasks and just completed one get-ahead task. Primary objectives that were completed today was the relocation of an external control panel for the European robotic arm, moving it from one operating area to another. They also tested a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. The get-ahead task that the duo was able to complete was the extension of the Straya Boom 2 from the Zarya module to the Poisk module. The crew just finished tying up the bundle of protective coverings and the LFM ring, or the launch fixture mechanism ring, that they removed earlier. They tied it to the Straya Boom 1, and the crew is now heading back towards the hatch. Unlike a U.S. spacewalk, time begins and ends for a Russian EVA once the hatch opens or closes. So once both of the crew are back inside the hatch and it is closed, that will conclude today's spacewalk. The crew is currently performing tool inspections prior to returning to the Poisk airlock. Currently in orbital nighttime, Oleg Artemyev and Denis Matveyev, along with the International Space Station, are flying 266 statute miles above the South Atlantic Ocean.
Oleg, Denis, are you facing each other? Yes, it's in work. Getting there slowly.
Подойдите друг к другу поближе, чтобы осмотреть скафандры.
Can you move closer to each other to check out the Orlans? Okay, more. Let Oleg move closer. Okay. How is it going? Going well? Inaudible. More. Move inside first. There you go. I guess it's fine now. And you can check my spacesuit now. Okay, well, what can I say? Not too bad. Should I move up? Okay. Okay, that's great. And we forgot about the second retainer. Well, I guess we were told not to swap it. Yes, we aren't going to do that. Please finish up Orlan checkouts and go back in. Okay, so now on to the gloves. Inaudible. Okay. Guys, so what's the status? Do you need to use wipes to clean anything? Well, I guess we could clean up the gloves because they do look sort of contaminated. But other than that, it looks fine.
Олег, у тебя перчатки грязные или у вас обоих?
Oleg, did you say that your gloves are unclean, or is it for both of you? Inaudible. Okay, copy that. Go ahead and retrieve the towel from the kit that's near the EV hatch. And also, do not jettison the towel. Wipe out the gloves and tie it down on the handrail. Okay, copy. Tie it down.
Да, то есть сначала делаем узелок вокруг поручня, а потом...
Yes, make sure that you make a knot first near the handrail. Inaudible. So it's the handrail here? Inaudible. You can tie it down later. Make sure that it does not float away all the way to the hatchway. Yes, a bit farther. So give me this one. Okay, here. I'm holding it. Okay, done. Now it's not going to float away anywhere. It's just going to disintegrate at some point. And we need to secure it with wire tie anyways, right? Inaudible. Well, it looks beautiful. Indeed. Copy, Oleg, and please start ingressing the MR module. Copy.
If you're just joining us, we're wrapping up the coverage. Well, sorry, we're about to re-ingress the hatch on the Poise module
So what is it?
for Russian EVA or Russian Spacewalk 54A. Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev, both of Roscosmos, exited the station's space-facing port on the Poise module at 8:25 a.m., 13:25 GMT. They have completed the primary objectives of the spacewalk, which was to relocate external control panel for the European robotic arm from one operating area, moving it from one operating area to another, and to test a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. The duo was ahead of the timeline for about 50 minutes throughout the day and was able to do a get-ahead task. They completed that get-ahead task, which was to extend the Straya Boom 2 from the Zarya module to the Poise module. We currently have live views as Oleg Artemiev has re-entered the hatch or the airlock, and we are waiting for Denis Matveyev to ingress as well.
Okay. Now let's do this hook.
Unlike a U.S. spacewalk, time begins and ends for a Russian spacewalk once the hatch opens and closes. So we'll be looking for the hatch to close before we call it the end of the spacewalk.
So now past the box. Okay, here it is. So let me think where I can put it.
Так, можно включать сушку сублиматоров.
Oleg, you can activate the sublimator. Okay, I think one of your hooks is holding it. The fixed length tether hook. Oh, you attached it? Okay. Okay, move to the right. Yes, like this. Yes. And bend your legs.
And currently we see Oleg Artemiev helping Denis Matveyev back inside the hatch, moving him inside the airlock.
Okay. All right. Yes. So shall we start drying? Drying, eh? Yes. Yes, guys, activate the sublimator drying. What about thermal controls? Do we turn it on as well? Okay, I think it's actually working now. So the switch, heat, cold, it doesn't matter what position it's in, right? Inaudible.
Олег, Денис, ручку тепло-холод ручную поставьте в третье положение на сушку.
Oleg, Denis, please put hot-cold switch to position 3. Okay, what about thermal control?
На самом деле,
You can deactivate the STR.
отключайте СТР.
But it doesn't really matter. Once you're in the manual mode, it makes no difference. So you can just deactivate it. Okay, EV2 deactivating thermal control.
Олег, Денис.
Oleg, Denis, go ahead.
Выключайте камеры Хеки. Ерки можно оставить пока.
Turn off Heka
Снятие защитного кольца.
cameras, and
Мы уже календарь перевернули.
after that, proceed with the removal of protective rings. And in Moscow, it's already September 3rd, by the way. Already? Who would have guessed?
Так, а вы Хеки выключать будете? А то, Олег, мы
Hey
наблюдаем.
guys, don't forget to turn off the Heka cameras. EV2, Heka are off. What did you turn off? The Hekas. Oh. Mine is still working. Okay, I'll turn it off now. Can you reach it? Let me help you. Okay, it's off. Heka cameras are off.
Защитного кольца.
Copy. Now start with inaudible. Okay, protective ring, protective ring. Listen, why don't we do the box first, because it will not let us stow the cameras. Let me hand you a hook. Where do you put this? Okay, hold this hook. Okay, so the config is nominal. Copy. Inaudible. Okay, so now we do the ring. This lock is not easy to operate. Okay. Let's fold it. I'm standing by for your report about removal of the protective ring. We know. In work. Okay, I got the second one.
Так, сушка ТО норма.
Okay, Sushka TO drying is nominal. EV2 already had this. Yeah, ground confirms EV2 already had this indication. Oleg, Denis. Go ahead. How are things going with the protective ring? Protective ring has been removed and we are now folding it for stowage. Copy. After this, you will have to inspect sealing surfaces on the hatch. Okay, so we're looking at the seal here.
Резиновые уплотнители в норме?
Please report this condition of rubber seals. Are they nominal? Yes, they are nominal.
Принято. Тогда приступаем
Copy.
к закрытию выходного люка.
Please proceed with closing the EV hatch.
Констейн на панели 201, карабин.
Attaching safety to panel 201. Copy 201.
Денис? Yes? Денис, how do you copy? I copy you. There's a little bit of noise.
Жду доклада о работе с ручкой выходного люка.
It's time to do the EV hatch cover. Okay. The handle is installed. Inaudible.
Ручка установлена. Ты уже начал движение вращать?
Copy, handle installed. Did you start rotating? Yes. I'm trying to get into a position for this. Copy. Talking over each other. Okay, standing by for the report about handle operation. Okay, pressing. Okay, good. Okay, rollers are passing behind the tabs. Inaudible. So is it working out? Yes. Okay, the hatch is closed. Copy. EVA elapsed time 6 hours 47 minutes 30 seconds. Congratulations on the successful EVA. You completed more than you set out to do. Very productive EVA. Tomorrow we'll do a debrief. Wait, did you say 6:47? Yes, 6:47.
Ребят, спасибо большое за работу.
Guys, thank you very much. I am handing over to Dima for a repress. Thank you so much for your great work today. It's been a pleasure as always. Good luck with the repress. Thank you. We'll talk to you later.
Олег, Денис.
Олег.
Сколько показывает на дисплее? Это
Денис.
стыковки бортовой колодки.
7:54.
Inaudible. Mine showing 754. Mine is 755. And actually the EVA time was not 6 hours 47 minutes. It was 7 hours 47 minutes. You say 747? Yes. In my book it's 747 or 748 even. Oleg, Denis, this is Dmitry for repress. We are ready. We are ready. Talking over each other. Use the repress procedure in the EVA book. Okay, let us turn around.
Сергей, для Дмитрия, по шлюзованию ты с нами, я так понимаю, готов с нами обратно в шлюзование?
Sergey, for Dmitry, are you ready to support the repress?
Да, достали обратно шлюзование.
Okay, we have the repress procedure handy. Copy. Oleg.
Готовим шаг 4.
Section 10, step 4,
start on my go. Copy. Step 4. So after 610, we execute on your go. Okay, I am in place. PHO hatch is closed. Copy that, Sergey. Oleg, if you're ready, you can start. Step 4, MRM2 repress to 260 millimeters from PHO.
If you're just joining us, we just wrapped Russian EVA or Russian Spacewalk 54A with an elapsed time of 7 hours and 47 minutes. The hatch closed on the Poise module at 4:12 p.m. Central Time, 5:12 p.m. Eastern Time.
Indicator illuminating.
Expedition 67 Commander Oleg Artemiev and Flight Engineer Denis Matveyev completed all primary objectives of the spacewalk, and they also completed one get-ahead task.
Pressure in suit 3-4.
The duo was able to install a platform with adapters on the Naoko module. They also transferred the control panel for the external control panel for the European robotic arm and connected it to the base point of the Naoko module. They also installed 2 gap spanners, a overrid 2 end effectors, end effector 1 and end effector 2.
Copy.
They also tested the grappling mechanism on the end of the European robotic arm, and they installed the Straya Boom 1 retainer. The get-ahead task that they completed was the Straya 2 extension from the Zarya module to the Poise module. The crew is currently inside the airlock and beginning repress operations.
Copy. Pressure in the compartment 130 in suit 02. Copy. Pressure in compartment 160, pressure in suit 016. Copy. Compartment pressure 200, pressure in suit 01. Copy. Compartment pressure 230, suit pressure 006. Copy. When pressure reaches 260, we will close KVD PHO ISU pressure equalization valve. Okay. Compartment pressure 250, suit pressure 003. And for EV2, pressure 004. Copy.
В отсеке 260.
260 in the compartment, 002 in suit. A close PHSU pressure equalization valve. Indicator is off. Alec, please report mana vacuum meter reading in MRM2. 265, copy 265. Sergey, what is the PHO pressure per mana vacuum meter? PHO pressure 291, copy. Okay, while we are waiting for the pressure to equalize, please continue executing Q card 11, transition to station power. Copy. Alec, Q card 11, step 6, we start with the combined tank pressure. Okay, what are we doing here? For MRM 2, get Becca 2 in. And Denise, this is sufficient. You don't have to check the others. You can press on. Okay. Okay, umbilical connector connect to the suit. Okay, first make sure that the switch is in the position for the next step. Complete. Okay, now attach umbilical connectors to the suits. You can help each other. Okay, I got one. Okay, now hand me the second one. Okay, ready. So what do we have next? So both umbilical connectors are mated to the suits? Okay, heat exchanger mode is coming on? Yes. Electrical umbilical attaching to the suit. Correct. Did you have the electrical umbilical? Yes, it's right here. EV2 electrical umbilical connected. Copy. EV2 connected. EV2 connected. EV1 connected. Okay, Oleg, please check the current pressure per vacuum meter because 5 minutes have elapsed. Pressure is 264. Okay, copy. Let's press on. After umbilicals are connected, operate the table SK1, SK2. So we first turn off the power on this one and then turn it on. Yes, transition to station power.
If you're just joining us, we are wrapping up the 253rd spacewalk for the International Space Station, Russian Spacewalk 54A. Expedition 67 Commander Oleg Artemyev and Flight Engineer Denis Matveyev, both of Roscosmos, concluded their spacewalk at 5:12 p.m. Eastern Time after 7 hours and 47 minutes outside of the International Space Station. Artemyev and Matveyev completed their major objectives, which included relocating an external control panel for the European robotic arm from one operating area to another and testing a rigidizing mechanism on the arm that will be used to facilitate the grasping of payloads. In addition, the duo extended a Strela telescoping boom from the Zarya module to the Poise module.
Okay, that's what we got. So Oleg, you transitioned as well? Affirmative. Okay, copy.
This was the 253rd spacewalk in support of ISS assembly, maintenance, and upgrades. This was the 8th spacewalk out of the ISS this year, the 5th spacewalk during Expedition 67. This was the 8th spacewalk for Artemyev's career, totaling 53 hours and 32 minutes. This was the 4th spacewalk for Matveyev's career, totaling 26 hours and 7 minutes. And today's spacewalk, again, lasted for 7 hours and 47 minutes.
And we'll keep monitoring. And Sergey's stabilization is coming to conclusion slowly.
And with that completion of today's task and the crew being back inside the hatch and airlock, we will conclude today's broadcast. Thank you for watching. This is Mission Control Houston.
We are on step 6 of UCART.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
Of traveling in a city. That solution was found in November of 1923 when an inventor named Garrett Morgan came up with the answer. After witnessing an especially bad accident one day, Morgan designed and patented a 3-position traffic signal, which used an automated signal with an interim warning position, the predecessor of today's yellow caution light. With this invention, cities around the world began to adopt this new technology, making the streets safer for cars and pedestrians alike. That fundamental change for city driving came about 100 years ago. Ironically, today, there is a situation in our modern world that is in need of a similar solution. But it will take more than adding a yellow light to solve this new problem. NASA, the FAA, and more than 100 industry partners have tackled the proliferation of unmanned aircraft and the need to regulate and manage these small drones. Just in the past few years, more than an estimated 700,000 unmanned aircraft systems, or UAS, have been purchased and are flying around our skies. With the push for these unmanned aircraft to be used in our daily lives for tasks such as delivering goods to our doorsteps, monitoring traffic on highways, recreational uses, and for medical needs, to name just a few, imagine what our world would look like in a few years if a dependable system of control was not put into place. Many have questions how such a dramatic change to the airspace will affect our lives and safety, and with that, NASA has set out to create a research platform that will help manage large numbers of drones flying at low altitude along with other airspace users. Known as UAS Traffic Management, or UTM, the goal is to create a system that can integrate drones safely and efficiently into air traffic that are already flying in low-altitude airspace. With UTM, package delivery and recreational flights won't interfere with helicopters, airplanes, nearby airports, or even safety drones being flown by first responders. On this episode of NASA X, we will examine this award-winning UTM technology and see how it works, and better comprehend this innovative system. We will also take a look at the dedicated NASA team at various field centers and its government and industry partners to understand the work accomplished developing and testing new software in real-world research. And we will see the system in action and find out when these new innovations will come online. Not too many years after the first flight at Kitty Hawk, North Carolina, NASA's predecessor agency, NACA, began developing technology and systems that have revolutionized the way we fly. NASA took over this workload from NACA in 1958 and has continued to pave a path forward for the aeronautics community ever since. As the premier science and technology agency in the federal government, it makes sense that NASA was once again tasked with understanding and developing a new system to make sure the drone technology would be world-class and safe from day one.
Well, there's a lot of reasons NASA's doing this work, right? So we can have a nice working relationship with industry as well as with the government side, the FAA, the DoD, DHS, DOI, that whole alphabet soup of folks that are interested in this space as well. We can bridge that gap between industry, the public, and them, as well as bring our experience in the airspace and in aeronautics in general to solve the problem, right? So building that coalition, coming up with unique solutions, testing them in the field, making sure that we have all the parties involved. That's really the sweet spot where NASA sits for this kind of thing.
NASA teams have been looking at unmanned aircraft technologies for quite a while, trying to better understand how large, medium, and small drones will begin to be integrated into our national airspace. Early conversations with the Department of Defense just needed NASA to help transition unmanned aircraft into the U.S. airspace. But those needs began to transform to a bigger picture almost immediately.
When we got involved in this, it was a pretty simple problem that we were trying to solve. DoD was bringing unmanned aircraft back from theater. They needed to move them from one base to another. And so the question was, how do you get these very high-performance unmanned aircraft up into Class A airspace. So take off from restricted airspace and move through Class E airspace up into Class A. And that, that's real geeky sounding and all, but for the FAA people, this is really important. So that's what we thought the problem was. After we had started working in this, just for a couple of years, along came this package delivery. So a whole new mission and a whole new set of actors came out. So it took on a whole new meaning. NASA then got very interested in how you manage the traffic as well as what the characteristics of the vehicle should be. So when we first started, it was all vehicle-centric. But then as we got real interested in UTM, or UAS traffic management, took on a new meaning of how do you manage all of these vehicles around. And it has just blossomed for that into hundreds or thousands of use cases, and everybody that could possibly think about delivering some service or some product to a household or between businesses now has an interest in the work that we've been doing.
With the knowledge of building a completely new system that would fundamentally change how vehicles move in our airspace, the team needed to carefully understand the major issues. So they took a step-by-step approach to make sure they were moving in the right direction. They first had to lay out the goals, which included, but were not limited to, allowing diverse, small UAS mix and airspace use. For example, package delivery, safely enabling scalability for the future, and establishing a highly efficient, predictable, safe, and affordable airspace operations system, all by developing and validating integration requirements and providing prototype software UTM systems for the FAA to further test.
So NASA developed this concept called Unmanned Aircraft System Traffic Management because we are expecting millions of drones and their operations in a day, which is magnitude order different than what happens with current aviation, where there are 50,000 aircraft, and at a time there are about 6,000 at peak in sky. So the question is, how do we manage these millions of drones without burdening the current air traffic control system? Now, there are fundamental differences in the way the manned aviation works and the drone operations will work. First of all, there is no pilot. Second, that these drones are small. Third, we can actually take advantage of digitization and connectivity across these drones by exchanging information to each other. So the idea of UTM is taking advantage of modern technology, making sure we don't overload the current air traffic control system. Now, one of the big parts of UTM is this managed by exception paradigm. In today's operations, air traffic controller is the only one that has all the information on the radar display. With UTM, we can connect all the information, and that information can be shared across all the operators in the sky. That allows us to basically say that just tell me what not to do, and I will figure out a path that will avoid other vehicles in the sky.
As PK mentioned, the system is a bit different than the air traffic control system used by the Federal Aviation Administration for today's commercial airplanes. UTM is based on digital sharing of each user's planned flight details. Each user will have the same situational awareness of airspace, unlike what happens in today's air traffic control.
Well, with the projected number of new drones coming in the commercial markets for the very large number of drones and operations, it's obvious that the current air traffic management paradigm, a human air traffic controller communicating with one or a handful of vehicles, will not scale up to the number of operations of commercial drones that people are thinking about. And so a new way of controlling this traffic had to be established or thought up. And this So NASA came up with the idea and vetted it through the FAA and industry to have this automated system that really did not rely on human air traffic controller interaction. And a key to this is that industry would be providing these services. And this would foster competition and economic growth and such for the system. And so this whole development of this traffic management system, not manually controlled by the air traffic controllers, but by automated systems provided by third-party industry commercial providers, really is a major change in the way air traffic management will be done in this country, and necessary to satisfy the vast number of new entrants in this growing drone market.
You think about the different ways that this system will impact people's lives. One simple one is ordering things online, right? In the future, you may be able to order something. It could be delivered to your house by drone in minutes to hours as opposed to days. That's one use case, right? So people can say, oh wow, that would be neat. Also, you can think about public safety, right? For example, fire departments. One thing they would like to do is to send a drone out before the truck can get there, right? It's possible for the drone to get to a site faster than a truck can, and they can survey the scene before their folks actually arrive. So again, that's a public safety feature that people can usually feel good that our system, a system like we've designed that may be implemented in the future, could help support. So let's imagine both of those things happening at the same time. Someone trying to deliver a hot dog to your house, and then actually a fire happening and the fire department wanting to get through. The system enables those kind of interactions, and it keeps the airspace safe, it keeps things from falling out of the sky, it keeps all the stuff working properly.
To begin problem solving, the team created 4 individual technical capability levels, or TCLs. TCLs are a risk-based development and test approach. TCL-1 served as the starting point of the platform, with drones flying simultaneously at 6 test sites, while each test site operated on their own schedule. TCL-1 focused on areas of remote population, low traffic density, rural applications, and work on notification-based operations. Researchers conducted field tests addressing how drones can be used in agriculture, firefighting, and infrastructure monitoring, and working to incorporate different technologies to help with flying the drones safely, such as scheduling and geofencing, which restricts the flight to an assigned area. After completing these valuable tests, the team then moved into the second stage of the testing, TCL-2. For TCL-2, NASA performed a 5-day flight test at the Nevada test site, with additional flights taking place for the national campaign at an additional 6 FAA UAS test sites. This testing was focused on monitoring drones that are flown in sparsely populated areas, where an operator can't actually see the drones they're flying, known as beyond line of sight operations. Researchers tested technologies for on-the-fly flight adjustments in controlled airspace and technology to clear airspace for search and rescue missions or for loss of communications with a small aircraft. As the UTM team monitored these flights, researchers also introduced simulated aircraft into the same airspace occupied by the drones to add more complexity in the system. The drones flew profiles that simulated real-world uses, such as package deliveries, farmland surveys, infrastructure inspections, search and rescue missions, and video surveillance operations. This work was proven successful, and the team quickly moved on to the next phase, TCL-3. TCL-3 was flown at the 6 FAA-designated test sites and focused on creating and testing technologies that will help keep drones safely distanced and flying in their designated volumes.
The UTM project also included the development of onboard technologies to help mitigate the risk from drones, both for those in the air and on the ground. These technologies are designed to help recognize and address potential problems while in flight and without human intervention. One of these technologies allows a drone equipped with special sensors and software to autonomously sense and avoid other aircraft.
This capability level also tested vehicle-to-vehicle communications in areas with moderate UAS traffic density. Testing also included UAS ground control interfacing to locally manage operations, communication, navigation, surveillance, human factors, data exchange, and network solutions. Drones were also flown beyond visual line of sight and in close proximity in altitude and distance. The focused technology flight tests were conducted at Langley and Ames research centers and complemented the flight testing conducted at the designated FAA test sites. Both provided valuable information of the flight performance of the drones necessary to work within the UTM system. Since UTM is a new way to manage air traffic, human factor data collection in real-world conditions is critical to understanding the human-system interactions.
We're really breaking new ground on the way human operators interact with complex systems. And so being here helps us get data on exactly their experience with this system. So for example, we are kind of monitoring the communication patterns that they use. So UTM as a system is exchanging lots and lots of data, and that data can be presented to those operators in a variety of ways. And they also have other ways that are not UTM to communicate with each other. They can communicate with each other over their radios. They can communicate each other through like texting applications, right? So we're kind of measuring all of those communication patterns to see what things are they talking about through UTM means and what things are they talking about with outside of UTM means, to really give us a sense for how well UTM as the system is supporting operators in conducting their operations.
Finally, TCL-4 demonstrated how the UTM system can integrate drones into urban areas. Corpus Christi, Texas and Reno, Nevada were chosen as the test sites, offering the right mix of challenges to prove that UTM could work anywhere. The cities have large populations, many obstacles to avoid, windy weather conditions, reduced lines of sight, and fewer safe landing locations. TCL-4 addressed these challenges using UTM systems and technologies on board the drones and on the ground. These include incorporating more localized weather predictions into flight planning, using cell phone networks to enhance drone traffic communications, and relying on cameras, radar, and alternate ways of seeing during flight to ensure drones can maneuver around buildings and land safely, all while communicating with other drones and users of the UTM system.
Over the kind of the progression of this project, where we are now is the most complex piece of it, right? So now we are testing in urban environments, in higher density operations, looking at kind of contingency or off-nominal situations. So that list of three things, urban environments, higher densities, off-nominal situations, those are all extremely complicated things to tackle. And so for us to be here tackling those things is the only way we could learn some of the things that are associated with those things. That would be all very difficult to learn in a laboratory setting. There are so many things that are really an opportunity that come from the geographic locations in which we are testing that give us these types of this data, everything that we learn from being here.
Although all this research took place here in the U.S., this new structure will be the framework used around the world.
UTM idea, concept, architecture is out there, and it's been endorsed by ICAO, the International Civil Aviation Organization. And if you look in Europe and in Asia, countries that are starting up their version of UTM, they're starting with this architecture that NASA developed. And so it's really out there, and we're participating in international standards groups to really kind of consolidate what the concept is and harmonize internationally.
The influence of UTM on future projects, I think, was something we're pretty proud of, right? The concept and the way of managing the airspace is really new. And people are seeing application of that to, for example, UAM and air taxis, potentially for high E operations over 60,000 feet, space traffic management. All of these things can leverage what we've learned in UTM because it's about providing services to classes of operations where services aren't provided now and probably won't be provided. Right? So finding a solution to that really has benefited future work as well at NASA.
It's clear to see that a tremendous amount of planning, research, flying, design, and hard work went into this project, and that the UTM framework is here to stay.
I think we're really getting into a whole new era of aviation, right? Where we got completely new operations that weren't there before. We are envisioning a few years from now, maybe 10 years from now, a world where we'll be traveling through cities in small electric aircraft, for example, and we'll have some drones delivering medicine or delivering food or things like that. All this is really only going to be able if we set like a foundation where we can use our great new automation capabilities, networking capabilities, really making use of digital ways to coordinate all these different operations and all this air traffic in a way that just wasn't possible before. But the only way that we can actually do this is by shifting the paradigm entirely from this very human-centered approach that we've been taking over so many years to safely manage all this traffic that was existing for these new operations, to take an approach that is a lot more built around safe frameworks in which the different technologies can interact with each other, and where they actually are going to be able to provide the first level of safety layers and the core components of organizing all this traffic.
UTM is enabling airspace operations and providing access to users that was never possible before. It's opened up skies in a way that we can now enable different types of operations in the airspace, and we have a way to manage the traffic because of UTM, which gives tremendous societal benefit of reaching places, cargo as well as people, that was not possible before.
Low-altitude airspace is leading a revolution in flight, and a multi-billion-dollar industry is emerging as a result. At no time in history has aviation been poised to enter the lives of so many people. From package delivery to first responders to safety inspections to video documentation, every person stands to benefit in ways we have only begun to imagine.
We're really at a once-in-a-lifetime opportunity to be part of aviation. We see new aircraft that like we've never seen before. We have new types of software systems, scalable and cloud-based. We have new companies that are entering the space that we haven't traditionally seen in aviation so far, and we have really great collaboration amongst industry to work together, as well as collaboration with the FAA and aviation authorities to go ahead and make that happen. And that really sets us up for the next 100 years of aviation in a way that we haven't seen before.
The research and development completed on the UTM project has come to a close, but that doesn't mean that the final chapter of this technology has been written. NASA and its partners are planning future research and testing to mature these systems to the point that one day soon, flying drones in our neighborhood will be as common as seeing yellow caution signals on traffic lights. With the success of NASA's UTM project, that day is much closer than you may think.
Scan, the beginning. And we see that communicating to, from, and in space was all NASA, all the time. Our satellites, our infrastructure, our people. Today, some 6 decades later, filling the vacuum of space communications is competition. Commercial industry has come a long way in the past 40 years, and now may reliably deliver most of those same satellite services to space-based users in the near-Earth environment that were once the exclusive domain of NASA. So, NASA Space Communications and Navigation, SCAN, will be investigating viability of the commercial space-based networks to meet the needs of NASA missions flying around Earth. Once demonstrated, NASA intends to move away from government-owned and operated systems and procure commercial comms services. NASA cares about the health of the U.S. satellite industry and will work with everyone to promote industry growth, innovation, and interoperability. By 2030, NASA SCAN expects to migrate from the current paradigm of operating and maintaining government communications systems to a new one where NASA is just one of many commercial customers in an interoperable near-Earth space, exclusively shopping the commercial marketplace for the best and most cost-effective services to support our closer-to-home NASA missions.
Liftoff of the Falcon 9 and Crew.
NASA expects the space-based market to grow tremendously over the next few decades. Like the successful Commercial Crew program, NASA SCAN will trust its more routine, time-tested tasks to industry innovators and collaborators who'll partner to expand satellite industry norms and standards and embrace interoperability. They'll augment existing processes with autonomous operations and navigation services critical for meeting user needs in a highly congested and dynamic environment. Scientists and mission engineers will seamlessly roam space-based relay and direct-to-Earth communications networks, enabling them to immediately access the freshest data, download the most recent revealing imagery, and at a moment's notice, nimbly turn satellites and telescopes to cover breaking science, like a volcano erupting unexpectedly or a supernova appearing suddenly in the night sky. All in a user-friendly experience as simple and seamless in space as a call with your smartphone on Earth. And the money NASA SCAN saves in near-Earth orbit will help fund game-changing technologies elsewhere, such as multi-GNSS receivers that work at the moon, multilingual space receivers that can be reconfigured on the fly to communicate and negotiate with any provider for access to their networks, and systems like optical and quantum, literally the waves of the future in NASA deep space communications and navigation. Scan the future, and we see greater efficiency and sharpened focus for NASA. And for our nation and its workforce, a more competitive, innovative, and interoperable space communications industry. NASA Space Communications and Navigation. SCAN. Exploration enabled.
Humanity has always been interested in exploration. If we really want to go to the moon, we have got to figure out a way to keep our propellants cold long enough. My name is Monica Guzik, and I have the coolest job at NASA because I work with cryogenics. Cryogenics is the study of things at very low temperatures. We've got electrical connectors we can plug into. So we want to store things like oxygen or hydrogen, but if you store them as a gas, the only way to get a whole bunch of molecules in there is to raise the pressure really high. So instead, if we make them really, really cold, they turn into a liquid, so they're way more efficient to store. So this is going to be a liquid oxygen test. I always knew I wanted to be an engineer since I was a little girl. My dad was an engineer, and I just thought engineering was so cool. We were going to put insulation over this. Ended up getting a summer internship here at NASA Glenn Research Center in Cleveland, and just really sort of fell in love with NASA. Cleveland is the rock and roll capital of the world. I really enjoy rock and roll music, so I try to go to a lot of concerts. When we improve cryogenic technologies for space applications, it always has a trickle-down effect to the Earth. Now we're rolling into the Artemis generation, and we're still doing that.
This is Houston. Are you ready for the event?
We are ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me? Houston ACR, our station has you loud and clear. How us? Sound great. Please stand by for opening remarks.
Hello and welcome. My name is Kate Naff, and I'm the Virtual Programs Coordinator for the Denver Museum of Nature and Science. We're thrilled to have you joining us today as we connect live with the International Space Station. The cosmos has long inspired humankind, and today, the chance to speak to astronauts living hundreds of miles above Earth's surface is just a further testament to how far human knowledge and science has come. In preparation for today's program, we had students and potential future astronauts from across Colorado pose questions for the scientists aboard the space station. In a matter of minutes, these questions will be answered live. And so, without further ado, we would like to thank NASA for this incredible and unique opportunity and turn the program over to them and, of course, the International Space Station.
My name is Anais, and how do you become an astronaut?
Thank you for that question, and I just want to say at the very beginning here how delighted that Jessica and I are to join you all at the Denver Museum of Nature and Science, and we thank you for this opportunity. How do you become an astronaut? I think the bottom line, it requires hard work, but if you are a pilot, you need to have 1,000 hours of flying time in high-performance aircraft, and many of our pilots come from the military, from the Air Force, Navy, Marine Corps. And then if you are a mission specialist like Jessica and I, you need to have an advanced degree. You need to study extra hard, and that degree needs to be in the areas of science, technology, engineering, or math. Jessica is a geologist. I'm a physician, and we both it's an extreme honor and privilege to get to serve our country in the capacity as an astronaut.
Hi, my name is Annabelle. Where does your water come from?
Yeah, great question. So we have amazing technology on board the International Space Station, which we actually are able to apply on the Earth as well, and will be using in the future as we explore further and further into the solar system. But that technology allows us to use the moisture that's in the air and from our bodies and recycle that water and turn it into drinking water. And so we are at the point where we are able to recycle about 95% of the water that we produce here on station, which is amazing and is going to be super helpful for us when we start going out to the moon and eventually to Mars, where we won't be able to resupply with water from Earth as easily. And so it's a really important technology to be able to create drinking water. And so we end up, at the end of the day, we end up with water that can go into a drinking bag like the one that Chell is showing you here and create water for us to drink. It's delicious.
My question is, how do you sleep in space?
So I'm still recovering from the water question. How do you sleep in space? Well, the easy answer, I think, for me is really, really well. And we sleep in sleeping bags. Our sleeping bags are in our crew quarters, which are actually just behind us here. And I have my sleeping bag just tethered to the crew quarters with one cord, and when I get into it, I will get into my sleeping bag, and then I'll just float around in my sleeping bag inside my crew quarters. And for me, it's like sleeping on a cloud.
I'm Addie, and my question is, what is your favorite thing about being in space?
That is a tough question because being in space is awesome, and so I actually have two answers. My first favorite thing about being in space is getting to see the Earth. So getting to look out our window and see the Earth rotating beneath us, getting to see everyone we know, everywhere we've ever been, and we get to see that 16 times a day. So the Earth rotates. We get to see 16 sunrises and sunsets every 90 minutes up here from the International Space Station. It's just absolutely gorgeous. And my second favorite part about being in space is getting to be up here with my friends. We have amazing crewmates. There are 4 of us here on Crew 4, Chell, myself, Samantha Cristoforetti, who's working hard behind us, and Bob Hines, who is working hard over here. And so getting to work with them as well as our Russian colleagues is just an absolute honor and privilege.
Hi, my name is Gabe, and my question is, what does it smell like in space?
Hey Gabe, that's a great question. And this is my second mission, and when I got back to the space station, it smelled just like I remembered it, and that is the smell of space. So once we have a vehicle, a spacecraft that is docked with the space station and has just been exposed to outside, or when we bring a spacewalker back into the space station, it has this kind of a burnt metal smell. And so every time we open a hatch and are welcoming a new spacecraft, you smell that smell, and that has a very distinct smell, and I've never really smelled it back on the Earth. And so it was really cool to get back here to the space station and to experience that smell again.
Hi, my name is Ibrahim, and my question is, what if debris damaged the space station?
That's a really good question, and actually there is a whole team of people on the ground who are fully focused on the answer to that question and really to avoiding that scenario and keeping us safe up here on this International Space Station. So that team is looking out for any pieces of debris or any particles, satellites, anything in space that might have a similar trajectory that would intersect with our trajectory up here on the ISS. And if that looks like that might be happening, then there are several things that we can do. The main one being that we can just change where we are. So we can change our orbit, and that way that deconflicts us from anything that might be on a similar pathway so that we don't end up colliding. So we are super grateful, super reliant on a whole team of people that keep us safe and productive and happy up here.
My name is Dara, and my question is, what would happen if your tether broke on a spacewalk?
It's a really good question. We have to be very careful when we're doing spacewalks, and so we spend hundreds of hours practicing spacewalks in the neutral buoyancy laboratory back in Houston. And that's we learn how to be very careful about using those tethers. And so hopefully what would happen is that we'd be holding onto a handrail and we would notice that tether broke, and so we would stop using that and start using a different one. If for some reason we were not holding onto the space station at the time and our tether broke, we have another tether called the safety tether that is holding us to the space station. If both of those tethers are broken, we have one last safeguard, and that is that we have a jetpack on the back of our spacesuit called the Safer. And this is essentially cold gas jets that we have a controller to fly ourselves back to the space station, and we actually practice doing that using virtual reality back at Johnson Space Center. We have great trainers on the Earth that prepare us for all of those possibilities, and so we're very grateful for that training.
Can you show us a backflip in space?
We're glad you asked. You got a double out of Chell.
Hi, my name is Allison, and my question is, what do they eat in space?
Allison, food is incredibly important, not only on the ground, but up here in space as well. Of course, we are all taught and we know that we need to eat a balanced diet that includes protein and vegetables. And so our food comes in two different ways up here. One is it's sealed in this kind of a greenish aluminum envelope. All of our food is pre-cooked. And so this is food that has been cooked on the Earth and then sealed in this envelope to keep it fresh. And when we're ready to eat, we stick it into a food warmer and it warms up. The other type of food is dehydrated food, and so here are some veggies that have been rehydrated. These are asparagus, and so that'll be for dinner tonight. And those are kind of fun things. Those are things that we need to eat to stay healthy. And then every once in a while, it's okay to have a little bit of a treat. And so here we have some candy-coated chocolate peanuts, and we really like these. Uh-oh. Got it. One more. And we like to have fun with those. They're tasty and fun.
Hello, my name is Bryce, and how does it feel before you take off?
Yeah, that is a super exciting, super fun, super overwhelming moment, sitting on the launch pad getting ready to finally launch. So we have years of training prior to a mission like this. When we first joined the astronaut corps, we have 2 years of essentially basic training where we get introduced to all of space station systems, robotics, and learning how to fly jets as well. And then when we learn that we are going to be on to a mission, we have specific training for that mission as well, and that can be anywhere from 1 to 2 years. And so when we're finally sitting on the launch pad in our seats ready to go, after all of that training, all of that build-up, it is just super exciting to have that culmination of a dream that's been, for me personally, something that I've dreamed about for a very long time. And then also the excitement of knowing that it is just the beginning, that it is a launch into up to the International Space Station, and that the adventures that we're going to have up here. So it is a very, very exciting moment having all of that come together at once.
My name is Luca, and my question is, how do astronauts walk in space?
Luca, that's a really interesting question. And we learn to, when we say walk in space, of course, spacewalk, that very specifically means putting on our big white spacesuit and going outside of the space station. But we have to get around inside the space station as well. And to do that, we can use our hands and our feet. And so you can see these blue handrails. We grab onto those to move around, and those are on the floor too, and that's actually, we have our feet tucked under handrails to keep ourselves in place, and so we can push off of those, we can pull on these, and so when you first get into weightlessness, you first get on the space station, you're kind of clumsy, and you propel yourself and you run into things and you knock things off the wall. But after you've been up here a while, you become very efficient at moving around, and you can get from one place to another just by grabbing 1 or 2 handrails and turning yourself and rolling and doing a flip and ending up right where you want to be. And it's really, really cool.
Hi, my name is Camilla, and my question is, have you ever dropped or lost something in space?
The answer to that question is absolutely. Almost every day, I lose something in space. It is really quite different up here to keep track of everything. So when we are working on a task and we have several tools and materials that we are working with, it can be really difficult to keep them all in your vision. We can let go of things like this microphone, and it will generally stay where you put it. But after some period of time, the air current in the space station will pick it up and take it away. And if you are not paying attention and you turn around, it can be gone forever. So we spend quite a bit of time looking for lost items, but they always show up.
My name is Sean, and my question is, what game do you play on the International Space Station?
Well, one of the games we frequently play is I Spy, when we're looking for stuff that Waddy has lost. Actually, there are a lot of things that we like to do in our free time on the space station, but I think most of all, we love looking out the windows, looking back at the Earth, and we love hanging out with each other. So those are the 2 things that we probably spend most of our time on. We have a voice over internet protocol phone through our computers so that we can call our family and friends back on the ground, and we really enjoy talking with them and catching up with what's going on the ground. But we also have an assortment of various sports equipment up here, mostly just to kind of have fun with, but every once in a while it's really fun to see stuff and how it behaves in space, things that we're very familiar with. Jessica is a rugby player and played on the U.S. national team, and so it's fun. I know it's fun for her to have a rugby ball up here and see how it behaves in weightlessness.
Hi, my name is John, and my question is, how do you guys deal with the gravity on the International Space Station?
so microgravity is actually one of the most fun aspects of being up here, but it definitely takes some adjusting. As Chow mentioned, when we first arrive, your body is trying to figure out how to work, how to think, how to move around in microgravity, and how to use the full 3D, the full volume of the space here on the ISS. And it's amazing to see how quickly that happens. It really is just in the first couple of weeks where your body really starts to figure it out, and your brain starts to map out the station in all different orientations, and it really becomes quite easy to maneuver around and work in this space. So it's been pretty awesome to see that happen.
My question is, what kind of exercise do you do?
Exercise is incredibly important, not only on the Earth, but here on the space station as well. So when we're on the Earth, we try to exercise every day. It's important for our muscles, for our bones, for our hearts, and it's even more important on the space station because being here in weightlessness, while it's fun, it's actually very hard on the human body. The human body adapts to it, and it's as if, because we float, because we don't have to fight against gravity, it's as if we were just laying in bed for 6 months straight. And of course, our bodies would become very weak if we did that back on the Earth. And so here in space, we have to do exercises to keep our bones strong, our muscles strong, and our hearts working well. And so we have an exercise bike and a treadmill for cardiovascular, for an aerobic workout. And we have essentially a weightlifting machine, a resistance exercise device that can provide up to 600 pounds of resistance to keep our muscles and our bones strong. And so we work out about 2 hours every day. And by doing that, we are healthy and strong when we return back to the Earth.
Hi, my name is Jennifer. My question is, how long does it take for your body to recover when you come back to Earth?
So I think it really depends on the individual person. For my last mission, well, let's just say there are a bunch of different things going on when you get back to the Earth. And for one thing, your inner ear that helps you with balance, you feel a little dizzy. Your inner ear is a little messed up. The vestibular part of your brain is a little messed up because now it's sensing gravity again. And that takes about 2 weeks to go back to normal. Our muscles, our bones, our bodies are not used to gravity, and so for me, holding my big head up on my neck has not had to do that for 6 months. And so when we get back to the Earth, your neck is sore, your low back is sore, your feet are sore because again, they're not used to holding your body up. That all gets better in about 30 days. So in about a month after you get home, you're feeling pretty much back to normal.
We at the museum would once again like to thank NASA and the astronauts aboard the International Space Station for making today's program possible. We would also like to thank the audience joining us, as well as all the students and families involved in filming prior to this program. May you continue to find inspiration in space, science, and learning. We look forward to seeing what comes next for humankind in space exploration and hope some of you will be the astronauts making that happen.
And we would just like to say thank you to all of you, our friends at the Denver Museum of Nature and Science, to Kate and Jessica and everyone who helped put this together. Thank you to the parents and especially thank you to the students. We hope that you had fun. We certainly did, and we look forward to you continuing to explore there at the museum, but also on your own, reading about science, technology, engineering, and math, reading about spaceflight. And we hope that some of you will come and join us and explore with us at NASA someday.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.
Wherever, however, whenever. We're here, there. We're everywhere. NASA Space Communications and Navigation. Exploration enabled.
Being an educator today is not easy. We here at Heights Elementary School are not here simply to educate our students in the academic realm. It's so important for our students to be lifelong learners, and we have to think about ways that we motivate them to do so.
There are so many distractions that we have to compete with.
iPads, Xbox, video games,
internet.
Far too many channels of cable television.
What we need is something that kids will be highly motivated about, something to keep them physically fit as well as making nutritionally sound choices.
What we needed was a new tool to help these kids think about diet and exercise in order to make the healthy choices they need to.
I knew what that tool was. It was something that inspired me as a kid and continues to inspire me today. The space program.
The importance of an astronaut's physical exercise and proper diet cannot be understated, not just for the fitness of the astronaut, but also to ensure that they stay mentally focused and productive during their stay on the International Space Station and for future missions, whether it be to asteroids, the moon, or Mars.
In response to the rising childhood obesity rate, NASA has developed a series of activities based on astronaut training, and we call that Train Like an Astronaut.
Examples of the Train Like an Astronaut activities include things that we do exactly as we do on the ISS: cycling, resistance training, and cardiovascular. And then onto dexterity, putting puzzles together, making healthy food choices, and working as a team. All activities as they truly do on the ISS.
Train Like an Astronaut activities are flexible enough to be used in conjunction with other programs like NFL Play 60. What makes this program unique is that we're using the human challenges of spaceflight to inspire as well as motivate our children to make healthy choices throughout their life.
We're currently in 24 countries with over 24,000 participants and growing every year.
This has expanded to such an incredible opportunity for both myself and for educators around the world to make such an impact on the lives of children, both with fitness as well as nutrition.
It was excitement for the whole thing that the students, they weren't just doing exercises anymore. They were training like an astronaut.
The true success of this program is the educators. An example of a teacher that has worked and motivated his children is an outstanding educator by the name of Tim Vigorito. This gentleman excited them and inspired them in ways that we never could do it. And with that, he's helping us grow the 21st century leadership that we so desperately need.
Mr. Vigorito is extremely passionate about the Train Like an Astronaut program.
I think he himself would like to be an astronaut.
He comes to life when he's teaching the kids and talking about the program. The kids feel that enthusiasm.
We're just so fortunate to have him. Oh, it's truly the case.
They say your astronaut training doesn't begin when NASA hires you.
Cool.
It begins when you're young, by learning about space and the world around us, and by making healthy choices in life. Today, I'd like to recognize an outstanding physical education teacher, Tim Vigorito, for being a champion for the Train Like an Astronaut program and influencing thousands of students to date.
Wow.
It is educators like you that truly make a difference in this world, and who will inspire the next generation to propel humankind on future missions to Mars and beyond.
This is too much.
For me, it's become a way of life, and I'm just so thankful to everyone for what it's done for me. I just want to share that with my students. Maybe it'll inspire them to reach a little deeper, or to go a little further, or maybe to try a little harder, whatever it is in life.
The International Space Station is the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world. And the result will help benefit the people on the ground.
Space Station really provides an opportunity to explore, for example, say medical applications.
The aging and the osteoporosis and muscle wasting conditions are greatly accelerated in microgravity.
The weightless environment will give us insights into things like diabetes and maybe even cancer.
Understanding those phenomena allow us to look at how we can improve treatment of disease here on Earth.
If we wouldn't have conducted experiments on the ISS, we wouldn't have known that you could use cold atmospheric plasma in such broad application areas we're now exploring.
One of the most promising results has been gained by studying a protein associated with Duchenne muscular dystrophy.
We may be able to slow the disease by half, potentially doubling the lifespan of many of these DMD patients.
We provided eyes-serve imagery for many natural disasters, including floods and fires, for deforestations, for volcanic eruptions, and for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
I think it's made people much more aware of the issues of water quality. That's a very powerful thing.
Having the HyCO on the International Space Station has been the ideal test bed for our research.
We can monitor these water bodies from space, and if we can reduce exposures both to humans and even animals, then we've achieved our goal.
And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The space station has done so many things for life on planet Earth. It shows us what human beings can do working together. It shows the science that we can discover.
Over 2,000 experiments have flown on board ISS. 170 countries around the world have participated in some fashion, either in the ISS itself or in one of the experiments. Our rate of research is actually increasing. We're doing more today on board the space station for research than we have ever done before, and that's only going to continue in the future.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
Carroll Township's a very rural area in northern Ohio, right on Lake Erie. Lake Erie has always been very important to Carroll Township and its residents. We use it for drinking water, we treat it, and it's really our livelihood.
In Lake Erie, for what unknown reason, suddenly the toxin level spiked, and that got through the treatment system.
It was indicated to me that it is pretty dangerous.
Cyanotoxins can cause skin rashes,
headaches,
nausea,
vomiting, stomach problems,
nervous system problems,
liver damage,
to death.
We sampled, and we had about 2.5 times the limit from the World Health Organization. The second sample was approximately 3.5 times. Our plant wasn't set up to handle what was coming in from Lake Erie. One of my biggest worries was actually hurting someone, or even worse, So we shut it off right away, shut everything off. We had a very close call that day. The last thing you want to do is produce an unsafe water and allow your people to drink it. What we need is a better way to track and predict these cyanobacteria entries from our source water so that we can make sure that this never happens again.
A lot of times we'll find out after the fact that there's a problem with cyanobacteria in the water because the bloom's already occurred. We either get results of sick animals or sick people. We need a paradigm shift. We need to go from being constantly reactive to these blooms to having a capability that allows us to become proactive. And the U.S. Environmental Protection Agency has been very encouraging of allowing for some high-risk, high-reward projects. And that allowed us to think outside the box, way outside the box. We've been fortunate enough to make use of a sensor on the International Space Station called HICO, which stands for the Hyperspectral Imager for the Coastal Ocean.
HICO consists of two instruments. One is a camera, and the second instrument is a spectrophotometer, which actually gives us the spectrum of light leaving that water.
The camera on a cell phone, for example, contains about 3 bands of data in a red channel, a green channel, and a blue channel.
HICO gathers light from the red, orange, yellow, green, blue, indigo, and violet parts of the spectrum. So using this technology, we're able to now detect those water quality parameters such as water clarity, what the phytoplankton concentration is in your water, how much light is being absorbed in your water, as well as what's the distribution of cyanobacteria in those waters, and does that concentration pose a health hazard?
So what this means is instead of waiting for someone to report that there's a problem with cyanobacteria bloom, we can monitor these water bodies from space
and get information that we can rapidly get out to the water quality managers through a smartphone application that we've developed.
So the app allows you to drop a pinpoint, and that pin can be placed in an area where a drinking water treatment plant may have an intake, and see what the current water quality conditions were. Each user gets that information near real time, so they can make judgment calls on whether they have to respond or take action.
Having the HICO on the International Space Station has been the ideal test bed for our research.
This is an amazing partnership. The Naval Research Laboratory had HICO on NASA's International Space Station. As HICO acquired a scene, it was transferred to the Naval Research Laboratory. And then the Environmental Protection Agency was able to do the analysis and the validation to send this information out through a prototype mobile application. Yes, this technology will reduce costs and provide near real-time information. But the big goal here is protecting humans. And if we can reduce exposures both to humans and even animals, then we've achieved our goal.
As farmers and winemakers, we work very hard to grow the best quality fruit possible to make the best wines possible. The real polished part of winemaking is letting that wine age gracefully so those flavors can be preserved and brought to your home and to enjoy in the glass. The greatest issues we face as winemakers is that our optimal storage conditions for our wines are also optimal growth conditions for mold and bacteria.
Mold is really bad in a barrel room or in a cellar because it has an odor to it. And the wines are a living, breathing thing. And actually, they pick up the characters of where they're living.
The wines can absorb that aroma, and it's just not a healthy environment to work in. My father and I built this barrel room underground. The challenge is we've got some stagnant air which can cause mold growth. Who knew that our solution would be not underground, but up in the sky?
In order to carry astronauts to Mars for deep space exploration,
you have to be able to grow your food stores. You don't have enough space and capacity to carry them with you. So NASA began experimenting with growing crops in space. What they found is that in the growing chambers on the International Space Station, the crops they were growing were emitting a naturally occurring hormone called ethylene. It's a gas, and ethylene is the reason that fruits and vegetables ripen.
But the problem was in space we're going to have a very confined environment, so the ethylene concentration can build up, especially in a plant growth chamber. It basically destroys the plant. And so there was a need to grow plants in space, and we were good at growing plants here at the University of Wisconsin. And so NASA came to us and said, we've got a problem. I think you've got a solution. Can you help us?
Through the University of Wisconsin Advanced Astroculture Program, they developed an ethylene removal system that was successfully tested on a number of missions on the International Space Station. So the ethylene removal system that was developed draws air through a reaction chamber. The air is passed across a catalyst bed, and that catalyst has the effect of removing anything organic from the air. That includes mycotoxins, bacteria, viruses, and even mold.
It showed us that with the right technology, we can overcome the challenges of growing plants in space and enable future space explorers to grow their own food as they continue to explore the solar system.
The International Space Station program not only supports the technology that allowed us to get rid of ethylene in the Space Station astroculture program, but it also provides a great variety of technologies to exist that otherwise wouldn't have been possible.
Realizing that this technology could have tremendous benefits here on Earth, we developed the Arose air purification systems. Initially used in the perishables world for prolonging the shelf life of fruits and vegetables, not long after that, we realized because of the effects the technology has on mold, that the wine industry was a perfect complement for the technology.
This technology has been a real boon to us. It helps me sleep better at night.
But as you can see around the cellar, there's not a lot of mold.
Within 24 hours, the amount of airborne mold spores were dramatically reduced.
Within 2 weeks, about 99.9% of the mold had vanished on the walls.
It solves problems before they occur.
The room smelled fresher. It actually enhances your storage conditions for you to even make better wine.
It's really amazing when you think about all the innovations that are going on up in space, how they can come into a place as unexpected as a winery, which translates into benefits on your dinner table.
SERVIR is a joint NASA and USAID program where we're working with developing countries around the world and strengthening their ability to use satellites to address the many problems that they have, including floods, fires, harmful algal blooms, and other types of events that they have where they can use satellites to really make better decisions.
We're using space information to help decisions that affect people in the village where they live.
When there's a major disaster, governments around the world come together and they provide all of the satellite data basically that the world has to offer. But there's smaller disasters that occur in the countries that we work in that may not make the front page of the New York Times, but in that country it's a really big deal. We asked ourselves, could we make a difference if we had a dedicated imager for acquiring imagery quickly after natural disasters and to be able to provide that imagery back to the countries that need them, that have real decisions that need to be made with a very quick turnaround. As NASA, we looked in our own backyard and started thinking, could we use the International Space Station? The International Space Station was a really fantastic asset to take advantage of because it passes over 90% of the Earth's populated area every 24 hours. We developed an imaging system and we called it iServe, which basically is a camera and a telescope system that sits inside the International Space Station and can collect imagery when it passes over natural disasters or other events that we need to collect imagery.
Initially, we were planning to take a few pictures per day.
So we contacted all the USAID missions around the world, and in total we had more than 2,000 requests coming, for people who need images from ISS.
And we moved to like 1,000 images per day.
We provided iServe imagery for many, many natural disasters, including floods and fires, for deforestation, for volcanic eruptions, for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
And now we have a huge archives of images of areas around the world. So this is something that was not really there before.
iServe is an example of, in essence, making the International Space Station even more international and connecting space to village to better understand and protect our home planet.
From the solar winds to the mystical auroras, science is a way of knowing, a way to help us understand the world around us. But how do we learn about the things we see, and how do we make sense of the things we don't understand? Find out next on Real World. As humans, we're all really curious about the world around us. Science is a way of knowing, but what does science really look like? Let's drop in on some NASA researchers who are currently working from home. Dr. Nicolene Weil studies the sun and solar winds by analyzing data from spacecraft, like NASA's Solar Dynamics Observatory. Dr. Marilia Samara studies charged particles in space by sending rockets into the auroras. And Amber Versteinen is an undergraduate student majoring in atmospheric science. Amber's internship at NASA helped put her on the path to a career in science. Dr. Weil, can you help us learn more about the nature of science?
Science is about understanding the natural world around us. Science is about finding new information, which inherently comes with being wrong a lot of the time. By definition, you're exploring space and questions that nobody has really thought through before.
Dr. Samara, how do these questions drive the study of science?
We'll ask questions. We try and figure out what experiment might help us answer this question. We go for it. Usually we don't figure out enough. We try again. We had no idea how the aurora was created, but people would notice that when they had a compass and there was aurora going on, funny things would happen. So they knew it had something to do with the magnetic field.
Scientists use different methods and tools to gather a variety of mathematical data. Data may include images, numbers, patterns, shapes, and calculations that help model and describe the world around us.
So think of images just with like a camera. That's a remote data set. You can do it in optical light, the light that we can see with our eye, just like with a regular camera. But we can also look at the sun in other wavelengths, other types of light, like X-ray light, ultraviolet light, infrared light. And so those are give you other types of information about the sun. The other type of information that we can get is called in situ, and that means measuring directly where you are.
In the case of aurora, we're trying to launch and go over the aurora in what we call the apogee, which is the highest point from the ground, and make measurements there. By concentrating on the apogee, we effectively get a snapshot of how the environment, that space plasma environment, looks at that particular time at that particular altitude. It's surprising how much science is in just a couple of minutes of these measurements.
When we look at data for a long enough period of time, we can understand patterns in those data and really make sure we're not just answering one little question about the sun, but that we're really pulling all of the information together and making sure the big picture still makes sense of how we think the sun works. When good science is being done, it leaves room for us to change our mind, to realize we were wrong about how something was working as we get new information, and we have to refine our ideas about how the natural world is working.
Scientists do their best to understand observations with the knowledge and tools they have, but sometimes scientific explanations change.
So I think of science as basically a puzzle. We have tiny pieces of the big puzzle. Every time we have a new piece that actually connects, our image changes.
We do our best to describe what we see and what we're observing, and then we figure out which parts still aren't making sense. Sometimes a model will make sense and explain all of the observations that we have today, and then tomorrow the sun will do something totally different and we'll have new observations. And it's not even necessarily that the model was wrong, it's just that the model was incomplete.
It's important for all of us to understand the nature of science because we can all be scientists, asking questions and gathering data. Amber, you've had a chance to collect data during your internship at NASA. What were you studying?
While I was in high school, my first project was studying ozone and how it affected plants by working on an ozone garden that was at the Virginia Living Museum. An ozone garden is a garden that consists of like different types of plants, some that react to ozone and some that don't. So some of the tools we used was a meter stick to measure the heights of the plants. We used a rain gauge to measure how much rain all of the plants were getting. We used a thermometer to measure the air temperature that the plants were growing in, and we used a psychrometer to measure the relative humidity of the garden each day. The ozone garden research was really important because it shows how different plants grow more efficiently in different climates and how ozone has such a big effect on plant growth. This is really important to understand with our changing climate.
A new fact is really like a new piece in a science puzzle. As more pieces are added, the big picture becomes clearer and clearer. But it's important not to try to force any pieces that don't fit.
It's important when we do science to do our best to overcome our biases. Everybody has biases. It's important to be ready to be proved wrong.
Science is a human endeavor, and our understanding of science is constantly changing. Men and women from all cultures and backgrounds choose careers as scientists and work in teams to answer the questions we have about the world around us. So, how can you get involved?
So don't just sit there. Ask a question. Make an observation. Use all the tools you have to collect evidence. Even do a citizen science project. You could even do an internship, maybe even at NASA.
So what are you waiting for? Science is an amazing way to use math to help uncover grand mysteries in the natural and material world. Special thanks to Dr. Nicolene Weil and Dr. Marilia Samra for helping us understand more about the nature of science. And thank you, Amber, for helping us see ourselves as scientists. I'm Sarah, and see you next time on Real World.
NASA Marshall Space Flight Center is Science Central for the International Space Station. Our teams help astronauts conduct groundbreaking research in microgravity. We have supported more than 3,400 investigations from around the globe. Our operators work with researchers, commercial companies, and even students to expand scientific discoveries on the orbiting laboratory. Now let's hear how each flight controller position is critical towards making science happen in space.
Welcome to the Payload Operations Integration Center. As a Payload Operations Director, I manage the day-to-day operations of science experiments performed on board the International Space Station.
The science experiments on the International Space Station range from studying human physiology to dark matter and even growing plants in space. As a Payload Rack Officer, our job is to monitor and ensure the safe operational use of these experiments.
It's very important that tools and parts
are safely organized on the International Space Station. Every day, stowage engineers track the location of these items so astronauts can easily find them to conduct science experiments.
The PACOM team talks directly with the ISS astronauts, guiding them through science experiments and technology demonstrations. The crew are our system, and we advocate for them from the ground.
Analyzing, integrating, and communicating. These are the responsibilities of an operations controller. We ensure that the astronauts have the resources they need to complete their science experiments safely.
Sometimes even the best plans need to change. Timeline change officers work with NASA centers and scientists from around the world, developing the best plans for each science experiment.
It is important that science data is transmitted down to Earth. As a data management controller, I help to ensure that data from space station is sent to scientists around the world.
The Marshall Ground Control Team ensures that all ground equipment is fully operational, such as computers, servers, hardware, and software. We also make sure that all data is successfully sent to and received from the satellites.
Thank you for visiting. We hope you've enjoyed this behind-the-scenes look at how Marshall enables scientific discovery.
This is The Big Picture, an official television report of the United States Army, produced for the armed forces and the American people. Now, to show you part of the big picture, here is Master Sergeant Stuart Quaid.
At 10:48 p.m. Eastern Standard Time on January 31st, 1958, the attention of the American people was focused on Cape Canaveral, Florida, as a giant rocket was catapulted toward outer space. Few events in American history have been so awaited, prayed for, worked for, as the Army's successful launching of Explorer 1. Today's Big Picture will reveal the dramatic, suspenseful story of how the Army, when the prestige of the United States throughout the world had been shaken by events beyond its control, stirred the hearts and emotions of the American people with an epic display of scientific and technical teamwork. Our story starts 84 days before the launching of Explorer 1. The date, the morning of November 8, 1957, at Huntsville, Alabama. A sudden meeting has been called by General John B. Medeiros, Commanding General of the Army Ballistic Missile Agency.
Good morning, gentlemen. Be seated, please. I have a very important announcement for you. We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
This is what they've been waiting for. The deadline is 90 days. 90 days to put a satellite into orbit. A crash program, an emergency. And the American people had become aware of that emergency long before, when a Soviet Sputnik beeped its way across the skies. The reaction was one of astonishment and concern, for it was now known that a potential enemy was at least temporarily ahead in developing means for space travel. Reaction, counter-reaction. All at once, Americans were interested in the oncoming age of space, and with the curiosity came a mounting, swelling demand to get a satellite into the air on the double. But there were disappointments. It was an immensely difficult job, and the first American attempt with a Vanguard rocket was a failure. And that was the background for the assignment to the Army Ballistic Missile Agency on November 8, 1957. Put a satellite into orbit within 90 days. There was no sense of panic, as the capability for doing the job had been ABMA's since 1954. ABMA was a crack team headed by old pros of the missile field. Dr. Werner von Braun, director of the Development Operations Division, supervised over 3,000 scientists, engineers, and technicians with more years of practical experience than any similar group elsewhere. Long before a countdown starts at a launching pad, precise miniature replicas of the individual sections are made and subjected to numerous tests. And even the model work comes after a countless number of hours at the drafting tables. Each new experiment, each test means more knowledge, which may mean a change of design. There are often no precedents. It is creative work by creative men and women, absorbed in the fascinating problems of space flight. And it would be difficult to find a science which does not have something to contribute. Even as the research and design work, along with the incessant testing, goes on, the missiles take shape in the vast construction shops. In the development phase, no two missiles are alike. Each one contains changes and improvements on what has come before. All efforts are made to perfect the missiles quickly, but every day presents an obstacle course of unique problems. Even the welding, for example, involves special techniques needed to satisfy the very specific requirements of a missile. Now, added to the already numerous complications, the ABMA development team had the job of modifying an existing missile system for the purpose of achieving orbital capacity. The decision was passed down. Modify the Redstone ballistic missile, the Army's most powerful weapons carrier over a 200-mile range. Why the Redstone? It had proved itself again and again on the ABMA launching pads at Cape Canaveral, Florida. At Huntsville, Alabama, the steady success of the Redstone firings confirmed the feeling they were going to be the ones to put up a satellite. Work on modifications was accelerated around the clock. The tests of components, assemblies, everything that goes into the missile. Question: will a small piece of metal alloy withstand the hottest part of the rocket's exhaust? No guesswork. ABMA people have to know. The rocket's exhaust will be too much for the alloy. It melts. So they will develop a better one. But the final test at ABMA, the big one, where the results of thousands of tests are checked out, is the static firing. Held firmly in place, its rocket engines filled with fuel, the assembled missile is studied during full force firing. In the blockhouse sheathed in concrete where the operating controls and personnel are located, the countdown has started. A few seconds before firing, the water is turned on. 4,000 gallons a minute are required to cool the flame deflector of the test stand in this simulated flight, where the missile will stay right where she is. The countdown moves along to the fateful moment.